Okay, so this, I think we are live. Okay, so I'm gonna go ahead and share the link. So if people want, you can see it. Hang on.
Absolutely. Yeah.
I might have to just go to my channel real quick because
Okay. I know some people were expecting this guy, this other guy to show up. Okay.
Oh, that's the avatar you're talking about.
Yeah, that's the other guy. I don't want to really scare people.
Did you create that, Eric?
No, that's just the snap filters. They're just built-in snap filters, which is really cool. A really nice application of shaders along with machine learning. So I think it's a nice example I'll use with my students in a couple of my classes.
So as you can, if you look at that YouTube link, you can see that we're live on YouTube. Yay!
Oh, wow.
But we don't bring the internet down.
Hopefully not.
No, probably not today. Let's see.
All right. You gonna run the Jingo or the enter music?
I don't really have any enter. Well, I mean, I guess I think I might have something. Let's see. I don't know if you'll hear it. I can play. I was just listening to something, but then what might happen? Can you hear that?
I cannot.
I don't hear anything.
Okay, I can hear it, but it'll be on the.
It'll be on the recording.
Yeah.
Okay.
So there we
Excellent.
go. That's our intro music. I don't want to do too long because then we'll get like a copyright notice or something from.
Absolutely, unless you just chose some of that non-copyright music.
I don't know.
So do you?
Go ahead.
Yeah, I was just wondering if you wanted to, make an introduction or anything to what's the expectation.
Well, okay. So this real quick is the Aframe WebXR online Hacknight. This is our 18th Hacknight. We've done lots of. We've worked on lots of different code projects. We've done we've fixed the thumb controls for WebXR. We've done the gravity gloves. We've worked on persistent, whatever you call it, persistent world things. Post-it notes is something we've been sort of thinking about and collaborating on, and now Eric is here. He's the creator of CS1, and he's going to show us some new things. Eric, do you want to take it from there and talk about what you have in mind?
Sure.
Do you want to take over the screen too? You may, if you prefer.
Sure.
Okay.
Absolutely. I want to thank you and thank the whole community around the A-Frame Hacknight and to kind of get into this here. I've pretty much have been hanging out in the wings for the most part, taking part here and there in the Hacknights, trying to absorb what's going on for the most part, trying to understand kind of what shared set of goals amongst the people who maybe consistently will attend Hacknight. And what I've kind of come to realize is there is a lot of enthusiasm around XR, WebXR, around the use of virtual and augmented reality. One thing that I thought that I could bring to the table is this notion of kind of we're standing on the shoulders of giants. It's important to understand that the software stack that we're standing on oftentimes hands us these APIs and ways of doing things that are very non-optimized. I've come to realize this through my own efforts, which have failed, and have given me reason to kind of deep dive into certain things around optimization. So that's where I come from right now. I just wanted to share kind of like the context of some of my woes, what I've learned about. I am by no means an expert in this. I am a teacher and physicist by trade, computer programmer by hobby for over 40 years, and have found a lot of joy in the space. And I really appreciate the people here. So I put a presentation link up right there if you haven't noticed it. bit.ly instancing Prez. If you go to that presentation, you can kind of jump through the slides at your own leisure. I'm primarily going to focus around the ideas regarding mesh instancing. If I get too far off topic at any point, please rein me in. But I was initially planning on doing this in one fell swoop, and I realized it should probably be done in 2 parts. And then followed up with another thing that's kind of related, which would be merging geometry, another strategy for performance optimization. But I would like to just kind of put that out there first. I also said initially that I had planned on. Oh, can you hear me? Are you all right?
Yeah, we can hear you.
I can hear you.
We can hear you.
Okay, great. And another thing that I said, and I want to kind of air this right out there at the beginning. Last week, I believe the last thing that I said is I would pretty much go about this in just raw WebGL, and I did at first, but then I realized I was looking at, do I want to talk through setting up all these enum values for the, state machine and doing all these initial calls and setup, or do I want to just have enough abstraction on top of that to focus on what's the intended purpose here today, and that's to learn a little more about mesh instancing and empower everyone within their own kind of your own learning silo. And with that said, I decided to use the primary kind of touch point is going to be around TWGL, which is a tiny WebGL library. It abstracts just enough away, but I'm also going to lead you through some deep diving into some of the functions that we're going to be calling after the state has been set up for the most part. So I've been throwing around this word state for a while, so I'm not going to go any further without saying that what we're about to dive in here with is GPU code, some of it with shaders. And there's kind of a different abstraction in terms of the computational abstraction on the GPU that we're dealing with in this.
Go ahead, keep going.
Okay, the abstraction that I want to point out right here, that the computational abstraction of the state machine, it's a little different. It is significantly different, put it that way, than the stack machine. So I just want to point out a little difference between those before going on. We're so used to kind of like dealing with things in the CPU, and we're running our JavaScript. It's an interpreted language. And then the computational model that it's usually sitting on top of is mostly, for the most part, a stack machine. When you're calling a function, for example, and you're passing, like, let's say, parameters into the function, every time you do a function call, it will set up some new memory. It'll allocate some new memory, it'll scope it out and lay that out in the stack. And that is important to understand, that is different than the state machine. In the state machine, you're setting up all of your state, pretty much laying out all this memory and kind of defining that ahead of time before you're calling the function. So you're setting up the situation ahead of time with this state in the state machine, and then you're calling the functions on that state. And the reason that especially these graphics and on the GPU is using that model for computation is for the reason that the state a lot of times is going to be the same. A lot of the state will be the same. So to tear down the state and rebuild the state, to kind of remap out pointers to memory addresses that would just basically could possibly be the same, rather than changing every function call, is going to save, optimize at the, kind of abstraction level. So the state machine, when it's being implemented, when they're creating that OpenGL like API on the, for the actual GPUs, they're building out that with the instruction set, with the assembly set of words, and instructions for the GPU. So I always wanted to point that out before going any further. Let's go on. Who's talking to you here? It's not that demon person you saw maybe advertising for this, although I can definitely put that face back on if you would rather. But I'm Eric Eisman. I'm an educator and computer programmer from Auburn, Maine. I usually go by the handle of SirFizX, and I'm currently doing a rewrite, hopefully a proper first time write, actually, of the CS1 game engine. It was a hack first time through to appeal to some students' wishes. All right, so we're gonna start off here with what is GPU mesh instancing. GPU mesh instancing, is in a couple bullets here, is drawing multiple copies of the same mesh instance once, using as few as a single draw call. So the draw call, we can see this depending on the APIs. If it's just the WebGL API, the draw call might be elements, draw elements, and then inside of that you can pass in, GL triangles might be the kind of elements that you're drawing. So that would be an example of a draw call. You can also draw arrays as well. There's different draw functions that are in the web, GL in the OpenGL. Basically, the OpenGL 3.0 is what the WebGL 2.0 is based upon. It has a slightly less enums involved in the state and a little bit less functionality as well. But for the most part, it's the majority. It's most of it. GPU mesh instancing is useful for drawing objects such as buildings, trees, and grass, and other things that appear repeatedly in a scene. So that's, I think, important to know off the bat. So we want to make fun performance environments to play around in and to learn in and do all kind of other applications in. And this is just one strategy to basically do that effectively. The benefits are more pronounced when you have a significant number of vertices in the instance mesh. So whatever the mesh is that we're going to have multiple copies of, we're going to have more pronounced benefits whenever we have a significant number of vertices. If it was a single vertex for the mesh, then, which I don't see how I guess you can call that the ultimately trivial mesh, then it really wouldn't be useful to use this method. But when you have more significant number of vertices in the mesh, then you're going to see that benefit kind of grow. The benefits also arise from the ability to differentiate between mesh instances on the GPU and the apply per instance custom colors, vertex displacements, and more. And these are going to be done basically with mappings, if you will, to what we're going to call pretty soon these attributes, these vertex attributes. And they're going to be kind of these attributes are going to show up in these vertex buffer objects that get stored in a vertex array object. Okay, so throwing around some terms here and maybe some acronyms will be coming your way. Don't worry, because I'm going to provide much really good material that I kind of grabbed from here and there and put together, and I think it's assembled in a way that's going to really help a lot of people, as you will see here in a moment. This is going to be mostly actually engaged hands-on stuff, so I'm going to try to go through this a little faster. The mesh instancing APIs in higher level libraries, even as we go up from WebGL into the TWGL that we're going to look at today, or if it's 3JS, these mesh instancing APIs are simply ultimately assisting in the composing of the underlying vertex array objects, these VAOs, which we're going to find out here in a little bit, in an instancing pattern. It's basically, they're helping us use these underlying objects in a certain pattern, how to compose them and do that. And when I'm saying like VBO, for example, don't think I'm talking about a virtual body odor. Don't want to be thought that, don't want you to think that that's the case. That's could in other instances it might be relevant, but it's not here. Vertex array objects. So that's what I was just referencing there. Because underlying, I want everybody, we're going to take pretty much a top-down approach with this, starting because most of our shared experience is within the context of A-Frame, which is in that software stack. A-Frame is on top of the 3JS, right, for that rendering. Basically, it's a rendering engine as well as a scene graph kind of defining engine. So a 3JS gives us a scene graph, and it gives us that rendering engine, which are important for a lot of our experiences. Certain experiences, maybe you don't need a scene graph. Maybe you don't need an entity component system and so forth. And it's good to be able to decide when, what level you want to engage at within the stack and within the software stack here. So these vertex array objects are basically these containers for vertex buffer objects. I'm not going to read these slides to you. From now, you could read those, and I have a bunch of material that's out there. Not a huge amount, not an overwhelming amount of material, but enough material that you're going to be able to become fluent and dive down through the stack. As a matter of fact, I even did a little sidetrack into diving into metal, in fact, into the actual GPU itself. So I think I went too far away. So the vertex buffer object is actually something that goes inside that holds attributes. A vertex buffer object can hold different attributes like color. You're familiar with color, like vertex colors. You're familiar with UVs or texture coordinates, or you're definitely familiar with probably vertex position. Well, all of those can be stored in these vertex buffer objects. And then those vertex buffer objects can be stored in a vertex array object. So it's just a compositional abstraction set that's important to know that it's out there, because as you dive deeper and further optimize, then this can empower you in your applications. The index buffer object basically allows mapping between associated buffers. So the index buffer object, we can think of those as the indices, which are basically single bytes. And it's similar to the way pointers work. If you're familiar with like C++ or other languages that might use pointers, pointers are basically just numbers. You can just think of those as like an integer that's going to point off to some other number that's usually a longer number that's representing a memory address. So it's within the context of like a stack machine. A lot of times you have this notion of these pointers that are pointing off, and they have pointers as well in the context of the state machine and web.
I lost audio for a second. Eric, you still there?
Can you hear me?
I can hear Mignon. I can't hear Eric.
Can anybody hear me?
I
can't hear anyone.
Oh, I can hear.
I can hear you.
I can't hear Eric. Is Eric still talking?
Let me see if I can reopen closed tab. So I don't hear Eric. Can anyone hear me? Can you hear me?
Yeah, now I can.
Okay, so my settings just went crazy for a second there. I think we may have lost Eric for a second. I think he's going to log back in. SirFizX, we can't hear you, but maybe you can just refresh your browser. And also check to see that your microphone... Someone may have muted everyone by accident. So, yeah, so maybe unmute yourself. That might be the issue. You've been muted by somebody. Somebody hit the button that mutes everyone. That's what happened. So whoever did that, just be careful. Just unmute yourself, Eric.
All right.
Yeah.
That's all good. That's all good.
So go ahead.
No rush.
You can.
Okay, so I'll go back.
You're welcome to resume your presentation. Go ahead.
Okay. Excellent.
So actually, I was going to ask you a question, Eric. A short question.
Yeah, sure.
It doesn't have to be a single byte, does it? Can't it be a 2-byte index?
The index buffer, you're going to specify it is, but it can be. It depends on how many indices you have. If you have a whole bunch, then of course you can go to multiple byte. But unless if you have a huge number of indices, then you can't, because you have to specify the type for it anyway when you're in what we call the layout phase. So when you're basically going into that linear memory, which is what these buffers are on the GPU side, you need to tell the GPU how that memory is laid out. And when we're doing this mapping between the index buffers, or the indices, if we will, the index buffer object is going to hold references to like the index IDs. So the index IDs are going to be the actual, are the references. And the index IDs can be single byte in terms of the actual type that they're represented by, or they could be more, as Mignon was saying, especially if your index IDs are going to have a large range. So in a byte, really, you have 8 bits. So you have 2 to the 8th number of possible, indices. But if you're going to go beyond 2 to the 8th with the number of indices that you have, which is highly unlikely. I mean, at least in our applications in WebGL. Now, if you were doing, if you were working with the most high-level, GPUs and console systems, now you might be in the multiple byte. But I think you can pretty much assure that most of the applications that we would be doing would use single byte references. And what that does, it's similar to like pointers. It's just going to point over to the associated vertex data. In our case, it's per instance. But it doesn't have to be that way that you're using them. You still can use index buffer objects with indices, even if you're not using instancing. I want you to understand that instancing isn't really special once you get over into the GPU side. It's just a pattern of using. It's a way of using the array object, the vertex array object. It's a way of putting certain vertex buffer objects within them and mapping between the vertices with these with the index buffer, with the indices within the index buffer object. So I'm gonna kind of leave it there. It's just kind of get you thinking about that a little bit. I'm not gonna go into that any deeper, but even though I haven't really done anything other than throw some things out there first, I wanted to throw this fun fact. I shared this little image. This is something that a lot of us like to do, right? Maybe work with Blender, especially because it's free and it's awesome. So like to make things, and you want to make them very performant, right? You want to export a GLB, like a binary GLTF file, and you want it to really rock inside of your game. You don't want it to really take up too much in terms of a frame per second, or whatever the compute metric you want to use. So I have a little question here for the audience. How many vertices do you think this model has, and does this model use a texture? Who wants to take that?
Well, it looks like 32 vertices. At least it has 32 corners.
I would say it at least has I don't know if it has a texture. It looks like it has colors. Yeah, I don't know.
Okay, so let's explore. So you can tell, yeah, you can think that it could have like 32 vertices.
Oh, but it's indexed? Is it indexed?
But notice that on each side there's 3 shared vertices. And what that index, one of the benefits, just pointing out one of the benefits, and this extends also to outside the context of instancing. Now those shared vertices, there's 3 on each side, as you can see. If you take that 32 minus 6, it's actually what? 32 minus 6, right? 26. 26 vertices. So there's actually only 26 vertices. And for each vertex, you're thinking, all right, or maybe you're not thinking, how many bytes per vertex do you think this has? What is the data that's stored with each vertex, do you think? Because this is going to go to the overall thing. This is also like a pretest. What's the data per?
I think you could do it with just 1 byte, I guess. 1 byte for each coordinate.
32
Well, you would need the.
So yeah, so there's
32 vertices.
Yeah, there's so the 32 vertices. If we didn't have, yes, there would be 32 vertices if we did not share 3 vertices on each side. So there's actually only 26 vertices in this map because we use an index buffer object to kind of like map out which vertices get kind of like reused. So it saves us a lot. And it actually saves us more than, there's more than position for each vertex. That's one of the biggest fallacies that are out there when people are just kind of playing around at the high level. They're not thinking. As a matter of fact, the vertex is an abstraction. It's just talking about like a point in the model. Go ahead.
It has to have a length as well. You got to have a length, a position and a length.
So you got to
have.
So the position.
And you got to have.
Position is.
And you have to have a direction for the.
Well, here's the thing. You actually don't have to do anything. It's a state machine, and you don't have to map out any data. The state machine won't break. To see anything, you typically need at least a position. You typically need, and it depends on the GPU, because some GPUs, if you don't define like a vertex color, it will like default it to white, for example. So you could just have vertex positions without even have vertex colors or UV data, which people usually say is a texture coordinate. So these things like position, vertex position, color, normal data, all of those things are attributes. All of those things are attributes, and those are going to be coming into play here very shortly. So one vertex can have position data. That can be one attribute. Can have the color data for vertex colors. It could have UV data, basically texture coordinates. It could have tangent data. It can have like the normal data, binormal data, and you can even make up custom data. And this one doesn't even have a texture model. It's getting that ambient occlusion that you see kind of shown in that model. It's getting that because that data is getting stored in the color vertex attribute for this. So there's some really cool. So here's just a collection. Vertex buffer objects are quite flexible in how you use them. Those are basically what hold the different attributes in them, and then those in turn go inside the vertex array objects. And I'm just going to kind of jump through some of these slides, but I want you to understand that what I want to see from you is your own individual learning and kind of tell me what you've learned. And these are different strategies and ways of using the vertex buffers. It depends on how you're using the attributes in conjunction. So I'm not going to leave a lot of this to you to look at. There's some other comments that I found very wise, taken from different places. Buffers which will be used together should be grouped using VAOs, vertex array objects, to minimize the total number of calls required to set up for each draw call. So this is what we came for, really, is to actually do stuff, not to hear me talk. So if we can go to bit.ly mesh instancing, this will make a copy of today's project that we're going to work with. So if we can go over to bit.ly mesh instancing, what it will be is the glitch project. If you're not already signed in to glitch, you can just sign in with Google, and you are good to go. You can also sign in with GitHub. You can also just make a sign in with your email if you wanted to go off the path a little bit.
Is your glitch also called Long Iodized Wizard?
No, your glitch is going to be different because that link is to a remix.
Oh.
That's so that you have a remix right off the bat, so we don't even have to deal with that idea of a remix.
Nice.
So just go to the bit.ly mesh instancing, and let me just go ahead while I'm at this. Somebody can put that in the chat. I'm going to go ahead and put that in the chat as well, just in case. So if you go to bit.ly/mesh or instancing. So we're taking this top-down approach, but I want you to appreciate that I am first a scientist, and physicist, and I love science and mathematics and the engineering of it all. So you'll see some of the things that I'm doing are kind of influenced by that. I'm going to jump over here to that project that you did a remix of. I will make my own remix of it here in a second. So I'm going to actually I should just close this out because this is the original one. And let me just go to the bit.ly. I'll just type it in. Mesh instancing. I'll just be doing the same thing that I asked you to do. So I'm not going to do something different. All right, so this is making a copy of today's project right here. Just going to do an overview of the README, and then we're going to dive right into the exercise. I've also realized that this is an extension of the Aframe community. This is the part of the Aframe community. So I'm going to ask, as this kind of boots up, that we put our observations. If you see right here, it says put our observations here. And what does that here? So throughout the exercises today, I'm going to ask you to post some observations. So I would like you to find out where that's at right off the bat, so we can build a community, build cohesiveness within the community, and build the top-down through the stack knowledge base of the community. I know there's a lot of people in the community well beyond anything that I understand, and I'm just, I come from as a teacher, I come from the guide from the side perspective. I'm the guide on the side learning along with you guys, and that's the way I approach it with my high school kids. So what I'm here to do is nothing different. So I'm learning this along with you, and I look at this as kind of like walking down that path together. And I got up in the morning and I ate some breakfast and I walked down the path a little earlier, and I came back and I met you at the cabin, something like that. All right. So over here, we're in the GLSL channel, or if you haven't already joined this channel, then you can join this channel at the Aframe Slack. If we can post into here, then we're going to really bolster the value of the entire community and the organization of the channel as a whole. Okay, so that's first of all. The exercises are here. I'm going to not click on those right this second. It's going to take us to some of the source code over here. But before we dive into the source code and the exercises, which will basically take us over to this JavaScript file right here, this is for part 1. I didn't put the link for part 2, which if you're not totally turned off by now, might happen in the future. Maybe even next.
I mean, I would just like encourage everybody to use the Discord instead of the Slack, because everything disappears that's older than like 7 months in the Slack. So
okay, then let's go ahead and all right.
Or Facebook, or Facebook. There's the WebXR, but whichever one.
Then can you place the Discord invite for the people that don't have it? That's a very good point. Because unless you have the corporate license, the professional Slack, you're not going to get all that old post, right?
Yeah. So the Super Medium Discord is the one we've been using.
Okay, that's great. That's great. So we're not going to be throwing away our intellectual kind of ramblings.
Yeah. And there's also the Facebook WebXR group and the WebAR WebXR group. If we want to.
Yeah, I think the Super Medium is definitely much bigger, and I think that's better to jump into the Super Medium Discord, because that's hitting the bigger part of the community, and maybe even making a channel in there.
Yeah.
I don't know if they have it set up so you can make a channel for that, unless they've authorized you with a special role. But let me go ahead through this. So basically. I wanted to kind of set the context for this whole discussion even coming up.
Okay.
I was going through this myself. So the link is in the chat right now.
So I don't know how to give people the link to the Discord. Actually, that's.
If you go into the Discord, you can click in the top left on the server icon, and you can choose invite. Get an invite link.
Okay. Top left, server icon.
And then you should be able to say invite or get something to that. I forget the exact phrasing.
Yeah. So top left.
I can go back to it. I actually closed my Discord just to try to get a little bit better performance.
Oh.
So I don't have Discord open right now where I do it. I will definitely. I will swing back to this. I will circle back to this in the end, just to make sure that everybody has that link. Or during the exercises, I'll swing back to it. So right here, I want to give you kind of the story that led up to this. Basically, I wanted to. My students were seriously. You give them a function where they can do some stuff and throw, or a procedure to throw some things into their project. They will throw the kitchen sink at it. They will throw everything at it, and it will just eat up all the compute. And they'll be hovering at 10 frames per second or 5 frames per second and wondering, what the heck's going wrong? What's wrong with this system? All right. So under the hood, I'm trying to make a domain-specific language in these APIs that are going to encourage like instancing or merging and these other strategies at the right times. And I'll talk to them about that as well, to be more mindful. And basically what it comes down to is being more mindful of memory usage and kind of turnaround in terms of tearing down and setting up memory on the CPU and the GPU. That's what underlies this. But I got to this Stack Overflow link as part of my deep dive into doing this thing. I shared that, and then I was asked to maybe share a little bit more, and then I put this together. So I kind of broke out that Stack Overflow information to the beginning part of the README, and then from there, I added some other information. Since this uses the TWGL library, which is a nice set of abstractions that's much thinner than 3JS and way lower than, considerably lower than A-frame. So if you go down below A-frame, you have 3JS. If you want to kind of get closer to just the bare WebGL API, then you have, but with a little bit of utility functions, then you have TWGL, which is the tiny WebGL library. That's what we're using here. So I think if we're taking this top-down approach, we should be able to maneuver as we're dropping down through the stratosphere, so to speak. As we're going down through, dropping down like we did a high dive out, we're doing a jump out of a plane with our parachutes and so forth, and we're kind of going through different stages of that as we're going down towards our landing site. That's what this is for here. This is getting you to read up a little bit on some of the underlying things that are in these TWGL API calls that we're going to be using. So I'm not going to walk you through all of this, but that's to help guide, because we're all coming from the A-frame world. We're familiar with certain 3JS things. Now, as we go down, rather than jumping directly into the WebGL API, we're going to go down through this other layer, which I believe is useful for this, and that's using this WGL library. And below that, I did a deep dive sidetrack to the metal, to the actual, semiconductors, the actual chips, the actual GPU itself. And I thought this was interesting, especially because I'm interested. I use this sometimes for in the context of not only graphics, some basic graphics, just trying some basic demos. Don't get me wrong, I'm totally a noob with this. But this is talking about the CUDA API for NVIDIA. It's also used as well. There's also libraries that are built on top of this for using the CUDA API and extending it to use it for machine learning as well. But this is interesting to understand that your GPUs are built with in a 3D fashion. It's laying out all these transistors in these this matrix. It's a 3D matrix. It's not just flat. If your GPU was flat, it would take up the whole room, for crying out loud. Your GPU is in a block and all these different thin layers, and it's a 3D layout. So when you get lower and lower and lower towards the actual semiconductor, then you're starting to think, should I lay out the memory? Since we're going to introduce the word layout today, should we use block linear memory, which is a 3-dimensional layout, actual in physical space on the actual chip. So I thought that was interesting. And then a little bit of math. I can't help myself. I always like to. So I share my favorite math channel, 3 Blue, 1 Brown. I'm sure a lot of you are familiar with 3D matrix transformations, which I think is a great video to step in that's relevant. The OpenGL, now this isn't WebGL, but if you're going to go use the CUDA API and kind of move over to some more native stuff, or work on, if you want to work faster, on certain types of single board computers or these little tiny chips, like IoT type of devices, then it would help you to read the actual OpenGL book. And these examples are going to be C++ based. And then I have the OpenGL docs right here, which is great for just looking up. And I'll just show this one, for example. This is a great look up search API or search blocks. So if you were looking at draw elements, if you were looking at draw elements for OpenGL3, I go over here, draw elements, OpenGL3, and then it will bring up the specification for it. And this is, you can go to the Chronos site. I don't think I linked to the Chronos site for certain things. Yeah, I think I did for the forum. Maybe I did. I don't know. I don't think I did though. The Chronos site is awesome. I love the Chronos site. I think this is simpler for navigating. And then there's the Cherno videos. If you haven't ever seen the Cherno videos, kind of this really cool Australian dude of kind of Russian ancestry, who is really awesome. He was a rock star. He worked for a AAA game company as a rock star engineer, and then he quit because he wanted to teach, and he wanted to pursue other interests. Awesome, a teacher at heart. So I found a couple of videos that just starting videos in OpenGL to start you off in there. Be explicit when possible. When you're passing in parameters into the function call, be explicit whenever you can. There is a GL enum called GL false. You know, in JavaScript, a lot of times we'll use 0 for false, right? It's better to say false than 0, right? If you can. It's more explicit, it's more readable by your colleagues and yourself when you go back to it. The same thing goes when you're in OpenGL land. There's a GL enum property called GL false. So I just pointed that out here, and also using expressions rather than using the result of the expression. And then down here, a couple pictures. I'm sorry?
There was nothing. It was just a yawn. Somebody, it wasn't me, but someone just yawned.
It's not because you're boring. It's just because I'm tired.
Okay. and then a couple nice pictures, and I'll finish with a video right here, and a couple pictures, another video and a channel that I like. It's just kind of specifying the relationship between VAOs and VBOs. And right here you can see it. Basically, these two pictures tell the story, but then he goes into some other things as well. So I put a bunch of, so I want you to say, I'm going to skip over things, but I took a lot of time to organize. I know it doesn't, what do you mean he just threw stuff in here ad hoc? No, I really did take some time. Maybe I failed, but probably didn't. So if we click on part 1 exercises, now we'll get into the actual exercises. And now we can, it'll open in a new tab, but that's all great. But it'll take you to the right line of code. That's what's really cool in a glitch. If you want to link a bunch of people to an actual line of code in the source code, not only the file, but this is taking you to, so this takes you to the right line. Here's the only limitation. Because I don't know ahead of time, I do not know ahead of time what the name is going to get generated for your remixes. I can't have this link to your individual source code. So you're going to have to be amazing participants and go into your actual source code, your remix source code, and find out where line 47 is. Hold it. What's the name of the file? app2 WebGL2JS line 47. So I'm going to do this along with you. I told you, I'm not going to throw you to the wolves here. I'm going to go over to my remix. I'm looking for app2 WebGL2JS line 47. So where is that? app2 WebGL2JS. And if you were thinking like ahead of time, why didn't he just link to our link? Well, because it generates a random name for your remixes, right? No, I wish I was that smart that I could guess all the random names that would be generated. That would be cool. But like I said, I'm just an average teacher over here. So before we go any further right here, of course you should read the code. You shouldn't just jump in the code without reading. I'll talk about this in a second, but I'm going to just focus on the exercise. We're just going to do the exercises first, and then we'll zoom out. We're going to get a little bit of a, so rather than getting, we're going to do the myopic thing, I guess. So right, we're going to look kind of just in this closed space, and we're going to focus on this first, and then we'll zoom out and look at everything. So right here, post your exercises here. Now, Micah pointed out that rather than this link, because we'd just be throwing them away, right? We should, instead of this link, we should have the, and this is where I said I was going to kind of zero back to the Discord. We should actually have the invite link for the Discord that we're going to be using. And we should actually have, we could actually have a link to the actual channel, because you can make links, you can actually invite to a specific channel. Is that in the chat now?
So I never figured out the link for the Discord, but
okay, I will do that then. That's all good. So I'm going to try to fire up Discord, and hopefully it doesn't disconnect me. I have all these things going. But I'm running on a simple MacBook Air.
But I was just going to say that I did add in 2 links to 2 Facebook groups, because it'd be great to grow those groups so that they are additional options for people to
Absolutely. I mean, we have people that are in those groups that have been like working at Facebook and Google and Mozilla for years and have a wealth of knowledge, and we can play off of those brilliant folks, and we can play off the questions of people like myself that are in there that just like to ask questions of smart people. I'm always asking questions of smart people. I love that.
Okay.
I love to ask questions of everybody. I've reached out to like Terrence Tao, Fields Medal winner. I've reached out to Alan Kay before a bunch of times, Turing Award winner. I've reached out to Rainer Weiss, Nobel Prize winner, and Philip Sharp, another Nobel Prize winner. I always reach out to people, always asking smart people things, and always trying to get answers. So I'm going to go down to and I have a bunch of servers here. I'm going to go down to the super medium. Where's the super medium? What's the picture on this? Where's that? Oh, wait. I know you'll probably see it before I do.
Yeah, I saw it.
Right?
Yeah, it's a good.
There it is.
There it is.
There it is. They all have Mozilla Hub there.
It's actually
super medium.
The icon is actually an S if you think about it.
That makes sense. So I apply super medium, where it says super medium up here, and I guess they don't have an icon now. It's just the drop-down menu. If I click over here, I can. I could just actually go invite from a channel. If I just go over to general, because I don't think I can. Yeah, if I go to click on channels, I can't add a channel because that's in their settings. I'm just going to go to general then, and then under the general channel, let's see here. I'm going to right click. Let's see. Copy the ID. No, that's not what I want. Where's that? Hold it. Where's that? Oh, no. There's no. Oh, there we go. Hold it. Invite server notification. Invite. Where's the invite thing? Crying out loud. Is it because I don't even have the. I'm not even enabled to invite on this server.
Maybe you need to be like admin or something.
Yeah, so you need it. So however they set up the server, you can set up the roles. Like if you go over my server, anybody can do an invite. So if you so let's just do it. Let me jump out of this super medium. So typically they'll put it on the internet though. Let's say super medium Discord.
Right.
Invite.
It should be on the internet somewhere.
Right, and it's like usually, and hopefully it's not an expired link. So invite. Let me just actually put invite in quotes. This is like the first day of my classes with my kids. One of the first things we do is we practice putting things in quotes and doing Google searches. Nice. What does a programmer do most of the time? Google searches. Okay, how to create a Discord or an invite. Questions. We also hanging out on Super Medium Discord. Moonrider Super Medium Discord. Is that Discord? HTTPS Discord. Blah blah blah. Let me see if this is. Let me check it.
Nice.
Because a lot of times the default. Is this gonna do it? Let me see. It might say it's expired. Did they make it last forever? Or is it expired? Invalid. The default, right? Yeah. The default is not to have everlasting. Here's another one though. This might still be valid. We'll check one more, and we'll see if it's valid. Otherwise, just go to the A-Frame Slack and ask Kevin, or go to the Super Medium channel, and you'll probably find it right in there. Okay,
we should make like a Heroku page that just has a permanent.
Oh, this is Atmos.
Yeah, that's not even this. No.
Super Medium. But I'm not going to dive down that rabbit hole any further. I am going to say that I do appreciate, and I'm totally down with that notion that we are throwing stuff away when we use Slack. And I'm going to start moving even my students away from using Slack. The school will, my school won't allow Discord.
Well, I think the Facebook groups are a good long-term solution. Those are going to be around for decades, I'm pretty sure.
Our school blocks Facebook too. Facebook groups are good too, but they also block Facebook. They don't block Twitter, but there's no right? You have no threading. You have no thread organization on Twitter.
Yeah, mostly what they've been recommending for people to use is the Stack Overflow, but that's it seems like that's limited to just getting your code checked. You can't really.
It is. I was just feeling. Yeah, you're shaming me today. I was just looking at my Stack Overflow rating. I never go in to boost my rating. I think I'm only 16 or whatever. I'm there's these other people this one student that I turned on to it, turned on the Stack Overflow side trip here when we were learning the Julia language together. He went on to publish 2 mathematics papers in college. Really, really smart. He had a Stack Overflow reputation of over 200 by the time he left high school.
Wow.
He started it his senior year.
Oh, wow.
He only started it his senior year and he had 200. He was so involved. And the community was so appreciative of the input that he put and the kind of detail that he posed. He was really into the we used LaTeX, for layout and stuff. And he was just, amazing. But yeah, I can appreciate Stack Overflow, and some of the people on it are just amazing. But here's the exercises. First exercise. Here it is. First thing I want to say is if you go show, it's not this is going to be what we're going to use for part 2. This is another example. This is not what we're using today. I didn't even post stuff in here about the part 2. What you have to do is actually go to 2.html. So if you open it up, go to 2.html. And this is the one we're using right here. So we're not using the one that just goes up with. We're not using the index HTML. Basically, we're using the 2.html. Basically, this is just, if you're not familiar with Glitch, this is just the static node server, but we don't see the back end of it at all. You can set up Glitch different ways. I just wanted to do it the simplest way with a static node server where you don't even see. This is just the public static folder.
Would you explain again, how do I make sure that the 2.html is the one that opens up? What's the...
Just put /2.html at the end of it.
Oh, okay. Sure, I got it.
Yeah,
so
I'll put it in the...
So yeah. I'll do it real quick on the screen. So I'm just gonna go to show, and then I'll put /2.html, enter. There we go. Okay, nice.
So the first exercise goes a little something like this. All right, no, exactly right. Who's the B-boy? Who are my B-boys out there? All right. Let's talk old school here, man. All right. So, what are the types of matrix position and GL position? So you're going to post your answers. You're going to be bold, right? You're going to shed a little shy. You're going to take a little bit of that shy and you're going to shed it, right? And why? Why are you going to shed a little shy? Because that's going to empower you and it's going to empower others. We're going to grow together, all right? So you're going to shed a little shy to die, okay, by answering these questions in the Discord, in the Super Medium Discord, right?
Okay.
There are kind people there.
Okay.
Right? There are kind people there. Don't worry about it. Which is not always the case, or hasn't always been. It hasn't always been the case at Stack Overflow, especially 10 years ago. 10 years ago at Stack Overflow, oh my God, it was an entirely different culture.
This is live.
This is live.
By
I never grew my reputation because I was stung so hard early on. I recoiled. Never wanted to post. But I want you, right? I want you to post your answers now. I want you to post your answers into, this isn't just sit back, right? This is active exercise right here. I want you to go into that Discord, go into the super medium Discord, go in there. If you can't find it, I guess you can post it over in the Slack for A-Frame. But go to one of those communities. You can go to Facebook, go to one of those communities and post about this.
The Facebook is going to be the easiest for the audience to reach, I think.
Right.
Today.
So what are the types of matrix position and GL position? After you've answered that, answer the question, how is GL position different from position? How is position different from position? All right, Homer. Homer. All right. So, yeah. I want you to know those things. Because I have to go through the trail of tears, right? The path, right? The path to the new place. Actually, it's not like the Trail of Tears. I shouldn't even made that reference, and I apologize to any Native Americans. But when I say Trail of Tears, I actually studied that as part of, I worked with a group teaching in an Outward Bound program where we actually studied the Plains Indians, and we did a lot of, so basically I just didn't do a good analogy right there. I said, because that wasn't a better place. It was the place Uncle Sam said. It was actually very, and that's why it was a drill. But anyway, so what are the types of matrix position and GL position? Who can tell me first, what is the type of matrix?
Which Discord, which channel? I just can't
Super
keep track.
medium.
Right.
Super medium Discord
channel. And now I can't even find the goddamn tab.
Super medium Discord, the general channel, if you can get in there. The general channel of the super medium Discord.
Okay, I got it.
And let them know we're here. Let them know there's see that the whole purpose of this too is to grab people from over there, have them jump in here right now. You know? They sometimes they'll have like hundreds and hundreds of people in that Discord. Let's get a small fraction of them at least on this.
All right.
Let's grow that. Let's grow the stack dive. All right. What's the type of matrix? What is the type of matrix on the GPU? What's the type?
Mat 4.
Right. It's a Mat 4, a matrix 4. So a matrix 4 is basically an array of arrays, right? It's a vector of vectors, more specifically. It's a vector of vectors. It's right. It's like a vec4 of vec4s. So the matrix 4 is a specific. A mat 4 is a specific vec4 of vec4s with some utility assigned to it as well. So very good. And if I had a little chocolate I can throw through the screen to you, Mignon, you would be the first to get it. If I had any Bitcoin, I don't have any Bitcoin either. But my humble gratitude is all I have to give. All right. So that's right. It's a Mat 4, matrix 4, which is like a vec4 of vec4s. What is position? What is that? And I should say it's a vec4 of vec4 floats. It's a vec4 of floats. It's a vec4 of vec4 floats. And position is what? What is it on the GPU? What's the type? We're so used to living.
I answered all three of them, so.
What's that?
I said I answered all three of them. It's vec4.
Let's get somebody else speaking up there. Somebody else unmute yourself. What's position?
Everyone else is muted.
Somebody else speak up. Come on. What's position on the GPU? It's a vec4 of what? Is it a vec4 of int, or is it a vec4 of floats?
That means floats, right? If you don't specify.
It's a vec4 of floats. That's right. Position is a vec4 of floats. Let's get some other people chipping in here. Right. Position is also a vec4 of floats. Right. if you're familiar with C++ or ANSI or whatever else, Rust. I love Rust. Don't get me started. Don't get me started with Rust, I tell you. Anyway, so going back to COBOL and Fortran 4, my first two languages. GL position. GL position, guess what it is? What's GL position?
VEC4.
VEC4 afloat, that's right. Let's get Micah B chiming in there on the next question. Let's get Micah B in the house.
You know, I didn't
over there.
I don't remember reading about this before the lesson today, so I'm not sure what I can add.
Oh, it was implicitly within the homework. If you would have read the code, you would have seen it.
So I did see the homework, but I didn't get to it.
So Eric, did anybody do the homework besides me?
No.
I will say that Mignon is sitting in the front, right beside the teacher's desk, because she is the only person that did the homework. Crying out loud. As a matter of fact, she is such an angel. She is such an angel. She also pointed out the fact that I realized that, and I was like, I had this terrible feeling because I was using the WebGL1 with the extension for the instancing, which is not identical to WebGL2 with the instancing, with the API, or with what the mapping is to as well. So WebGL1, the legacy, WebGL basically is a OpenGL2 implementation browser, and WebGL2 is an OpenGL 3.
So
well, at this point, I think it's still 3.0, but they're kind of moving up towards 3.3. I think we're 3, but we're up on 4 because they did some back subversions. Eventually, they'll get up to the 4.0 one of these days.
Well, I think I might have read the homework if you had said we were going to be quizzed live on YouTube.
Well, I tell you what, some people have to do it when they know that there is an extrinsic motivator. Other people just know within their heart of hearts,
okay,
that if they do it, they will get more out of life and more out of the day. And I appreciate seeing that in everyone. So Micah,
can I ask you a question? So it says here in your notes that the GL position equals the matrix times the position. What and you said the position is the vec4 float, but what does the matrix refer to exactly in this?
The matrix is a 4-dimensional. It's actually a 16-element matrix. It's a 4x4 matrix.
Okay.
So
okay.
If you've taken linear algebra before, right?
Yes.
Right.
Yes.
You talk about You talk about like B or A equals B cross or A equals B cross M, right? Or B times M. Whatever anytime you're multiplying a vector times a matrix, right? You're going to be using, just your matrix math, and you're going to end up with a vector of the same size back, right? So we're starting off on the left-hand side, which goes to what you said. GL position equals that position times the matrix. Now let's identify that, right? Let's actually go down to the relevant line of code down here. Okay. We're jumping ahead a little bit.
Okay.
Or no, we can actually just stay right there, I guess. No, that's good. So right there in this line, this matrix in this line is also called. Does somebody want to tell me what the matrix is also called right there? What is that? Within the context of graphics, what is it also called? I am willing to give a plastic cap to my drink bottle next time I see you.
Is it a world position?
Matrix world. It's the world matrix, basically.
It's the world matrix.
Matrix.
I was close.
World matrix.
I was close. Okay.
Yes, you are. Very good. I think you get it. Micah gets it. MB in the house. All right, that's exactly right. It's basically that, right? It's basically the world matrix, or some people will call it the camera transform matrix, right?
Sure.
Some people will call it the camera transform matrix. You don't have to have a camera abstraction when you're doing this. And you don't even have to do this. You don't even have to, because you're just working with memory and an API. You can keep it exclusively 2D. You can be working with the GPU entirely with 2D. So when you're building a camera, you can build a 2D camera abstraction. You can also build a 3D camera abstraction. Just wanted to say that another name for this matrix is the camera matrix transform. Another is the world matrix. It's a 4x4 matrix, a 16-element matrix, and we're multiplying it by a vector 4, and we're getting a result. It's also a vector 4 of floats. So and we're going to the final question right here in exercise 1, how is GL position different from position? Okay, go ahead. I'm progressively hitting myself harder in the head with a plastic bottle.
Okay, so the GL position is a world position, and the position itself is
yes.
Is
the other position.
The other position is not a complete world position. It's just
what do we call it? Not world space. It's right in linear algebra. These are vector spaces. There's world space, one vector space, right?
Okay.
World space is a vector space that exists in what? R3, right? World space is a vector space that exists in R3. You know, a real number, real number, real number.
Okay.
The position vector space also exists in R3, but it's different. It's not the world space, it's the what space. People that live around you are what?
I'm drawing a blank on.
Don't say that. Locals in local space.
I don't know.
Okay.
Position. Does that make sense? Position is a local space, right?
Okay.
Position
Right. Local space versus world space. Okay.
Right. So you have your position for like your whole object. Let's just think about that. Let's think about the object 3D. Let's talk something we're all familiar with. The object 3D, for crying out loud. The object 3D, let's just say that we have an A cube. We're in A-frame with an A cube. Oh, I can breathe now because I'm in a space that I'm comfortable with. I'm in A-frame with an A cube. I can set its position declaratively in HTML by saying position equals, and in quotes right there in the attribute in HTML, I can declare its position. Is that the position that this is? No, that's well, it might be if the individual vertex has 0 offset. That's the kind of like the reference position for the whole object 3D. Then each vertex within that object has an offset from there. Does that make sense? It's like what we're setting. If we made an A box, right? If we made an A box with position 111, that 111 is a position in world space. We're basically mapping world space to local space. 111 in world space is mapping to the origin in local space for that object. Does that make sense?
Yeah, and this would matter if you had more than one canvas, right? Like, because each canvas would have its own world space, unless you. Okay.
Typically, here's the thing. It depends on how you're using the canvas. Typically, when you have multiple canvases, you only have that one main canvas that's in 3 space, and usually the other ones are just 2D canvases.
Okay.
Usually, it doesn't have to be, right? The canvas is basically just what anyway? It's basically an array, anyways, right?
Okay.
When it comes down to it, it's the buffer anyway.
Yeah, I was thinking of ExoKit when you combine multiple different canvases together in a single page.
Okay, absolutely. I see what you're saying. Yeah, you could if you put them in a single page. but those would be, not only are those in their own single page, they are also running with their own threads. In JavaScript, with the way that that's running, they're running with their own threads as well to do that.
Right.
Right. They're not doing time sharing or work sharing on the same thread.
Yeah.
Because if it was on the same, if you have a single threaded application, you can do time sharing or work sharing. Those are two kind of strategies for virtualizing the idea of kind of like multi-threads within the single thread.
But is there a point when our local space, because if an object has, you can define it with a local space usually, but it still inherently has a world space that you can discover. And so what I'm kind of thinking are there examples of when the local space deviates from the world space?
Well, here's
then you have nested things, right? Like you have an object that has children, and the children have children, and so everything has a local example relative to its parent.
So yeah, exactly. That is a
perfect, okay. Yeah, I get what you're saying.
Example, right, of the parent-child relationship.
Right.
Now, how does that relate? How does that relate to, let's just say, the state or the matrix of each of those objects? If you have a parent-child relationship, in that case, there is either an additive relationship, which if it's position, it's just additive, right?
Right.
But if it's dealing with scaling, it's a multiplicative relationship, which is more along the lines of multiplying like a scalar times a matrix, right? So in the parent-child relationship, it depends. Each object has its own vector space, and you are operating on that parent. You're operating on that. You can think of it either way. It's like the inverse transform versus the transform. You can transform from whichever space into whichever space. But the transform from the parent to the child with position is additive, right? You're just going to be adding or subtracting from each of the respective components for the position. If it's dealing with scale, right? Scaling, obviously, scale factor. Scale is multiplying. So in that case, you're like taking the matrix that deals with all the vertices of the child, and you're multiplying that by the parent scale.
And we're rotating is additive, correct?
No, actually, yeah, this is interesting because rotating is typically is multiplicative. But if you remember from like high school geometry, you can express a rotation as like as a scaling as a combination of unequal. You can do like unequal scalings and translations to equal like a rotation. You can do or basically like multiple reflections. Remember how a composition of reflections can equal a rotation. Remember that?
No.
I don't remember taking linear algebra, but I did.
Well, no, this is high school geometry. High school geometry. A composition, that means one after the other of reflections. Any rotation can be expressed as a composition. Anyway, it doesn't matter. It's just, yes, basically, that is all important. That's why I shared that other channel with you. If you're not already listening to or watching 3 Blue 1 Brown, I put a link there in the other thing.
Great.
And it's perfect. You'll fall in love with it.
Yeah.
So we got the answer to that first exercise. Hooray! We finally finished the first exercise. You can do these all on your own. But so I'm going to comment out. Now I did this in such an ingenious way. No, I didn't. That even if you didn't comment like line 54, like I'm going to do, it will overwrite it anyway. When for exercise 2, when I uncomment line 57, it's just going to overwrite the GL position anyway. So even if I didn't comment but it's going to be a little bit faster, right? Because it doesn't have to perform this matrix multiplication over here. By commenting out line 54, do you see how we're making it faster than if we didn't? Not noticeably faster with this, but by comment outlining line 54, we are avoiding that matrix multiplication. And uncommenting line 57, now we begin the second exercise.
Oh.
Second exercise.
Wow.
Isn't that cool?
Yeah, that is cool.
Maybe it isn't. Maybe it's not cool at all. I just say that. I say that with my students too, and they just like smirk and laugh.
Well, I guess this is the first time I've seen that trick before. It's cool to me. So.
Oh yeah, always do that with them. But anyway, then I also give you some added kind of state to set. I didn't want to go and add a whole bunch of extra lines of code to alter the state. So I'm going to ask you to set the cubes across the 5, cubes down the 3, the X, Y, and Z of the camera, set them to those things. And then I want you to do this. I want you to change the Z to 90 and see what happens. Oh my, can we follow the instructions? Cubes across the 5, cubes down the 3. So we go to cubes across.
Wait, I'm not in the right
Change
thing.
it to 5.
It was
Cubes down. Cubes down. Oh, now I can see it. Now it makes sense. It's like I couldn't even see anything. He's lying.
Okay, let me
It's
see.
like, oh, doesn't even work.
So cubes. Wait,
No.
cubes across to 5.
Cubes across to 5. Cubes down to 3.
Yeah.
The X to negative 23.
Okay.
So that's the camera. X to negative 23.
Okay.
Oh, negative 23. I'm gonna just type it in. Negative 23. The Y, camera Y to 33. Camera Y, make it go to 33.
I am.
So.
Can you show me the code again? Because I think I'm missing a step in my mind. Let's see.
We're on line 56, and we're setting up the state according to what it says here. It's basically reading a comment.
Yeah.
We're setting the cubes across and cubes down. We're setting the camera position according to these 3 coordinates.
Yeah. But where are you setting that? Because you're setting
over here in the GUI.
Oh, now I got you. Okay, so that's what I was missing. I thought we were setting in the code. Okay, so let me do that.
Setting it in the GUI. Then we change the Z to negative 40. So I'm just going to type it in. It's just easier. Negative 40. Now I try to steal a lot of my pedagogical approaches here from really good teachers.
Oh, okay.
And so I'm gonna blame.
Yeah, so I got mine going.
My favorite. Actually, when it comes to code, it was with like MATLAB code.
Yep.
I forgot to share one person that I didn't. This actually. Let me load this up. Okay, I'll just wait. I'll come back to that maybe. Go over it. Okay, I'll come back to that. Let me just close this Slack then. All right. So, but somebody else, when it gets to the code lessons, something else I forgot to share. Mm-hmm. This person actually, 3 blue, 1 brown has better videos overall.
Oh yeah.
Yeah, this is actually, I don't want 2020 actually. I want the old videos.
Yeah, so by the way, everybody, I will take the notes from our chat here and put them into the YouTube description after we're done. Yeah.
Let me put this in, because I didn't put it in the README yet, and I might forget it, but don't. But this is how I actually learned linear algebra. From this guy online, and then I got to meet him in person and hang out with them and go to dinner with them. Fabulous gentleman, Gilbert, and Professor Emeritus at MIT, fantastic. And when it comes to introducing coding and changing things, he's one of the persons I refer to. And he has certain lessons and stuff online that you find there that do like MATLAB stuff. But here, what's wrong with this? So over here, if I change the Z to 90, what glitch goes away and why? So look what I'm having right now. So obviously there must be a glitch. But if I drag this to 90, there's still a glitch. If I drag it up to 90, now the glitch goes away. It actually goes away before 90. But what glitch goes away?
I don't understand what glitch?
There is a sort of pattern disruption that's really tiny.
Oh, okay.
Yeah, like a color
You see that?
color change.
What is that called? What is that called in graphics? That is called what? It's called a different thing.
Z fighting?
Z fighting. It's exactly right. It's Z fighting. See, we can go off on so many things. That's called Z fighting because with the precision, right? With the precision of the depth, right? Because there's a depth field, a depth buffer. We're not even through the first couple lessons and we're already talking about the depth buffer. So the depth buffer is gonna only typically have like 32-bit depth. It's not gonna have by default like 64-bit depth. So for the depth, when it's kind of organizing faces and vertices according to, the vertices first according to their depth, it's not going to, and then it does interpolation between them as it's kind of creating fragments and so forth. What happens is if it's too close, in how far it is away from the camera, I would just put it that way, then it does Z fighting, exactly what Mignon says. But why is that going away with what we're doing here? If I pull this, why would that go away? Doesn't that mean that, why is that, huh? Is it still, it's because of the view, right? It's because of the view transform is changing, right? We're changing the view transform when we're changing this Z.
Huh.
And that change, and that's affecting the depth buffer. But once we get those, even you can even see that happening at a lot of different other places. That Z fighting. So that's why that's going to introduce the kind of significance of thinking about the Matrix more often, not Keanu Reeves. It's right, yeah, I know. He's great, and the whole Bill and Ted revival thing is wonderful as well. But ultimately, this is getting us thinking about the depth buffer, how that relates to the matrix, the view matrix, the world matrix, if you will.
Yeah.
Right?
Yeah.
So, right? And not the view with Whoopi Goldberg, the matrix.
The VR matrix. We're talking about the VR matrix from the novel Neuromancer.
Yes. Okay.
Just kidding.
So, what's going on here, man? If you look what's happening with this, what did I do actually to get this different? Let's talk about what's happening here as well. If I go over here, every row, let's just use the word row right now. Row your boat. Every row is offset.
Nice.
As a matter of fact, we can say, and then also, I guess you can say to a certain extent, there's offsets within the individual instances of the cubes. So every row is offset, and then every individual cube is kind of offset. So that's offsetting.
This is a really great lesson, Eric. Really great lesson. A really cool project.
We're not going to learn the same thing.
Okay.
We're not going to learn the same thing. I actually attribute this style of teaching actually to a very young person, 20-something. This is the style that I'm using with you.
Okay.
And it's rather than, because I used to use recipe-based, and if I was teaching you data science with Python or something, I would use like an idiomatic approach, methodology for teaching. I actually talk about my methodology because I always have to think about it's always because we're all teaching ourselves, right?
Yeah.
And when we're teaching ourselves, we should use the methodology when we're teaching ourselves. We should metacognate about our process of teaching ourselves.
Okay.
So what I'm trying to do here, and I appreciate that, Micah, I really appreciate that, is Jacob Collier, and I can't stop, but this is people. This is because you're more important than anything else. And Jacob Collier just dropped a wonderful album this past week for streaming. He actually wrote it before, but he remixed some things, added some tracks. Jacob Collier, fantastic, genius. I got goosebumps just saying his name. And I'm gonna put that in there. He is a genius. He's a musical whiz beyond belief. But he talks about pedagogy as well, and kind of that's what kind of my short form thing for his. And he has some really short comments about it. But that's really appreciate that, Micah.
Sure.
So this particular, I want you to look at how I'm changing this one line from right here to here. This is the most generic thing for a vertex, for like a three-dimensional hello WebGL in 3 dimensions, not just the 2D hello WebGL, not the 2D triangle, but the 3D triangle. Once you get to the 3D, you can't just use positions, you also have to have the matrix.
Okay.
Technically, you don't. You're faking it. You can also just use offsets and kind of fake it, but you should use the matrix at that point and start using the depth buffer and things like that. But what I'm doing right here is I'm kind of encapsulating that as an expression, and then I'm building another expression that I'm adding to it. So I'm taking that starting point, that hello 3D WebGL expression, and then I'm adding to it. Because exercise 2 is supposed to add to exercise 1. And what am I doing? I'm adding a vector 4 to what we've already said before was a vector 4, right?
Mm-hmm.
I'm adding a vector 4, and instead of swizzling, which is, I didn't want to go through swizzling the first time if this is the first time you were swizzling. So we're not going to go through swizzling here, and you can always avoid swizzle, or normally. I'm going to explicitly, right? What am I explicitly doing? I'm constructing with a constructor for, this is one of the overloading function sets of parameters that I can pass into the vec4 constructor on the GPU for the, WebGL2. And basically the first component is going to be the float2 times the instance ID, which now makes you realize that what type must the instance ID be? Extra question. What type must the instance ID be?
It has to...
Well, it should be an integer, but you can't tell by looking at that.
Yeah, well, it shouldn't...
It is actually going... It's not an integer actually for the type, but it will cast to an integer without really losing essential information about it. So these instance IDs are going to be... What is it?
Well, where are you getting the instance ID from? Because I was thinking about the built-in instance ID.
So the instance ID, right, is going to be coming from within from within. We all need to look within. It's coming from the vertex. It's coming from within the vertex array object. It's coming from within its own special vertex buffer object.
But there's a special variable for that, the GL instance ID, right?
When you assign that, here's the beautiful thing, or not so beautiful thing. When you assign it through the JavaScript side, you're assigning it typically, unless you're being a troublesome lad or lassie, unless you're being troublesome, you're assigning it with just a regular integer. But technically it's what? It's a JavaScript number. JavaScript doesn't distinguish. People will normally just put an integer in there. But on the GPU side, all of those instance IDs become floats. And otherwise, I cannot multiply a float times anything else here other than a float, unless I was casting it into, but I'm not. Obviously, I'm not casting it. And then all of the other components of this vec4 are all floats, 0. I can't put 0, I have to put 0 point to make it, I have to make my point. Did I make my point?
Yeah.
And you cannot, no, you cannot, Micah, you cannot use the F, what the F, what the F? No, I'm not swearing. I am not swearing. You cannot use the F suffix in WebGL2. You could back in the day, back in WebGL1 with the extension, you could have used the F suffix. So when I say what the F, that's what I'm talking about. Get your mind out of the gutter. Crying out loud. Why do I even teach you this?
Okay, so you're using version 1.0 of GLSL?
Oh, good question. Did I learn from you? You were my teacher. Mignon, my teacher. Open up the JavaScript console. Open up the JavaScript console, and what do you see printed out there for your amazing? Look what's there. Because I already knew it was hidden. I already had it. I already slipped that into your cert pocket when I first came. And we are now at that trick. We are at that point where that trick is now
revealed.
Being revealed. That's exactly right. Oh, which I also have to put another link. I have to put another link. Another genius. I have to do this. I'm sorry. It's about the people that I love and learn from. And you're saying, what the heck? You're starting to realize more and more about me and getting more and more comfortable, and I apologize for that. You don't have to ever have me back. David Blaine is another genius. It's so many levels. 44 days without eating. 3 days in a block of ice. So many different cool things that he's done. And he's an incredible musician besides that. Anyway, so did that answer your question? Did that console log that was already there?
No,
it tells you
I'm
here.
talking about in the code where the code for the vertex shader. Don't you have to specify the vertex? What?
Oh, that's what you're asking for. Where is the shader code? This is the.
No, I see the shader. I'm looking at the shader code. And the first line of the shader code is not a version number. So that means it's version 1.0, right? So on line 34.
Yeah. Yes. Right. You're absolutely. Right. And here's the thing, and it's not in strict mode. So since this whole thing isn't running in strict mode with the JavaScript side, it actually allows me to do that. So the version number, so tell me what I should put here at the beginning of my shaders. That's very good that you point that out. So at the beginning, what you're saying is basically up here.
Yeah, but if you just change it, then it's not going to work, right?
No. Go ahead, let me type it in. What you're saying?
Okay, it's hash version.
Hash?
Version.
Space or just version like that? Space?
Yeah.
Version?
And then, well, let me find my code.
This is perfect. This is where you become the teacher.
Okay, space 300.
Exactly right.
Yes.
What is it?
Space 300 space ES.
What it says over here. 3.00 OpenGLES standard.
Yeah, but it said that before. I think that's what it supports, but that's not what the
Yeah. Well, that's
okay. See, now you have errors because
I'm breaking.
Because there's a different format, right. different rules in version 3.
See, this is where you become the teacher.
Okay, but this is not trivial. So I'm not saying that we should change this now.
Well, I did, and I'm not going back. No, I will change. I will go back right now, but I will remedy that because I know another thing. Yeah.
But I put an example. Did you see the link?
I'm just gonna comment. I'll comment it out for now.
Okay.
And then
but did you see the
back.
link that I posted after I did the homework? I asked you about the.
Yeah, I did. I saw that. You said you found it.
And then, so I posted a link. Well, eventually I got it working, and I think I posted another link after I got it working, right?
Ooh, I saw that you said you got it working, but I didn't read the stuff with the link.
Okay, but anyway, one of the things that's different, and one of the reasons I wanted to use version 3, is that when you use version 3, you get the instance ID automatically. You don't have to pass it in. There's a variable that's defined that's called GL instance ID, and it's an integer. So that's why I was confused.
Oh, okay, I got you. Excellent. So this implementation right here is still using, well, under the hood. Well, because I'm not the. Notice I'm not. This is kind of fun. This is kind of in an in-between world here, actually, right? Because I'm not. Notice nowhere do I specify using an extension. Look over here. Look.
Right.
You see? WebGL2, I'm not specifying any extension.
Okay.
Yet, you're right. Certain aspects of it do the 3 things, and other. So I'm in kind of a limbo land, and I will.
But it's a different version. The version of WebGL is independent of the version of the shader language, I think.
It is.
But isn't WebGL2 like limited to certain browsers? Like, isn't like the standard for A-Frame like WebGL1, or I don't know.
WebGL2 is an implementation of OpenGL3. WebGL1 is an implementation of OpenGL2.
Right. I thought. I mean, normally people use WebGL1 for WebAR and WebXR because 2 is not supported in every browser. It wasn't until recently.
Right.
It seems to be supported in Chrome, and that's the.
That's the only one that matters, right?
The only one I've been using for VR. Well, I mean, Firefox doesn't support WebXR.
Yeah, I mean, even Safari supports it now. They just don't support like a lot of the cool APIs. So, very good point. Now I understand where you were coming from with this, Mignon. That is awesome. Wow, bless you for that. That is awesome. So I'm going to make some clarification over that. I'm going to do this right. So what's this called anyway? This kind of line is called a what with the letter D? What's this actually called? This is called a what?
Oh, define? No.
It's called a compiler D. Compiler directive.
Okay.
This is called a compiler directive. So it tells the compiler whenever the compiler is going through building the, it's telling the compiler whenever it's doing the tokenization before doing the abstract syntax tree on its way down to building the, the machine code. So what is happening right here, this is an instruction to the compiler. That's what it is.
Okay.
But called a directive. But anyway, you can do directives and you can do macros depending on different compilers and so forth. But that is an awesome, super awesome point. I got goosebumps from that. That is awesome. Because I'm gonna learn so much more about these nuances between this, and I'm going to, this is gonna be awesome. I'm gonna engage some of these, some people with these, these questions and really deep dive into this. So ultimately, we're adding a vec4 to a vec4.
Yep.
But we're only right. So this, it's only changing the first component right here. It's only changing the first component. What are we saying with that? So we're only changing the first component. What's the first component of that thing? So it's obviously, I already went back and changed that, so it went away, right? So I got to put those back down, bring that down to cubes. I forget how many, 6, yeah. So I just do something like that, just move the Y. So if I move the Y, right, you just move the Y and the X. It's not exactly like we're flying the camera around, but it's, you know, it's not exactly that nice of an interface. But you can see that it's just giving them these offsets.
Yeah.
It's getting the, you know, it's giving them each this standard offset, because we need to get through the rest of these exercises a little bit. So I'm going to comment this line out right now.
All right.
Offset is awesome. So exercise 3. Exercise 3, we're going to uncomment line 68.
Okay.
Now everybody's going to be on their own little vision quest after this. Between now and next week, everybody will be on your own little vision quest.
Line 69?
You'll be going
69?
line 69, yes. Yes. And no, I didn't plan that. There we go. So this is, we're going to run this one. What's going on with this? Now we need to set up the state according to this. 3 cubes across, 1 cube down. Let's do that. 3 cubes across. 1 cube down. And then it says to x -6, y 12, z 16. The I is just to zoom in on it, you know, basically, right? So we're just going to use the y to zoom in a little bit more. Using the I to zoom in, I should say. So you can just play with these until you can like see it a little bit better.
The Z does zooming a little bit better than the Y, I noticed.
Yeah, because exactly, because the Z is front to back.
Yeah.
But now we have, and then the X and the Y kind of like, yeah. So it's a little bit different type of thing because it's doing the whole thing through translations. There's no rotation, right? Mm-hmm. So we're only changing of that world matrix. Right. Well, the way that we're doing this is we're not applying any rotational transformation.
Okay.
Oh my! Now they're getting the mignon now. Okay. Sorry about that. I apologize. But notice what's happening here. What's happening, man? Who blew up our little boxes?
What happened to our vertices that connected everything nicely?
What happened? What's going on? What's going on anyway?
Yeah.
Let's try to make some sense out of this. That's what this is about. So now what we're doing is we're doing really different, right? We're only adding something different. Now we're doing something similar to this exercise 2, but we're adding something different to it. So we're taking that hello world. We're taking the hello world vertex shader.
Yeah.
Which is the world view times the the position vector.
Yeah.
We're taking that matrix times the position, the hello world of vertex shaders, and we're adding to it a different expression this time. But now it's an expression that involves the vertex ID.
Yeah.
Not the instance ID. No. Not the instance ID.
Wow.
The vertex ID. So the instances, and we're going to do some reflection. We're going to go back through these in a little bit and go ask a couple more questions about some of the earlier exercises.
All right.
So, but the vertex ID, is every instance has, first of all, how many vertices? Looking at this, you should be able to tell me how many vertices does every instance have?
8.
Is an instance like a cube, or is an instance?
No. An instance is actually a cube. We didn't even get to that question. You leapfrogged ahead. For that, you get the highest praise I can offer right now, which is a thank you.
Okay.
Okay. But yes, the instances are the cubes. So how many vertices does each cube have?
24.
That is so correct. 24. And you should start to think now, something should start.
So did you shrink the vertices ID? You shrink the vertices ID? Is it? I don't really. It's the vertices ID. Why would that cause these to break apart like that?
Because look, I'm taking each vertex ID.
Yeah.
Because every one of these cubes has like vertex IDs 1 through 15. Does that make sense?
Okay. 1 through 15.
Every instance.
1 through 23?
Or I mean 1 through 23. Why would I say that? I want
Yeah.
to say your first. Yeah. You said 16 first. Yeah. 1 through 20. Yeah. Right. So like 0 to 23, if you will. The instance numbers are 1 to whatever. But yeah. So there's 16. The instance IDs are repeated for each instance. I mean, the vertex IDs are repeated for each instance. So you're offsetting each vertex differently based on its ID. So if you look over here, so the vertex number is getting multiplied by 0.1. So if it had the vertex ID of 1, it would be 1 times 0.1. If it had the vertex ID of 2, it would be 2 times 0.1. And so on and so on and so on.
Nice. So have you discovered that you can individually transform these vertex IDs? Because you're individually transforming the color.
We're leading you down that path because you asked that question last week.
Yeah.
That is so beautiful. That is beautiful. That was one of my guiding questions that I had to allow you to discover for yourself.
Okay.
Because I can never just tell something. This is what we're going to learn. These are the things A, B, C, D. Jacob Collier will tell you that straight up. You got to say, hey. You got to say, what do you want to learn? Or set them up with a situation like, what do you want to learn? And then say, oh, that's really worthwhile. And then you want to set up situations, experiences where they can discover it in their own unique way, because that's what's going to make all the connections between the chunks in your brain.
Nice.
And this is actually at the cognitive neuroscience. At the actual cognitive. Yeah.
Did you play that sound effect?
What?
Did you play that sound effect, or was there a race car outside your house?
No, it was not me at all. Who was that? It was somebody else doing that.
Oh, not me.
I gotta throw another person in here.
Go for it.
But
what's that noise?
I don't know. That high-pitched, kind of nails on the chalkboard kind of noise. Is that what you're talking about?
I believe it was the guest that just left. So we just
okay.
They were here and they were gone, and the noise went away.
Okay, so I'm gonna close a couple of. Yeah.
Okay, so I've been thinking about making.
All right. Yeah. So you see another one of my favorite YouTubers, but anyway. Sorry. But Bosch. Is it Jacob Bosch? Or no, it's not. What's Bosch's first name?
I don't know.
No, it's not Jacob.
Let's type Bosch.
MIT cognitive science. It's not even Bosch. I want to say Bosch like the drill. They'll find it. It's not Bosch. It's, oh my gosh, I can't believe I'm so terrible. I'll come up with it. He's just awesome. He's in charge of he's like a whiz at machine learning, but he's just like a cognitive neuroscience. He's just a wonderful person. He's from Austria, but he's worked at MIT. I'll get it. But anyway, he's fantastic, amazing. So basically, we're going to lead you down that path to discover that yourself. So we're going to ask you some questions, though, to lead you there, though. What does this view infer about the number of unique vertex IDs? And Mignon got that correct. There are 24 of them, or 24 of them. The next question, you should be posting this to Facebook or to the Discord. You should be posted in there. I don't see people not doing their work. I'm gonna hit my head progressively harder with this plastic bottle. So you post it.
So what? You wanted to type. What does this view infer?
What does this view?
Imply? Wouldn't that be imply, not infer?
Well, it could be infer or imply, depending if you saw the later code that actually explicitly said it, right?
Okay.
It could be an inference, and I was thinking of it, but it could be an implication as well. I was looking at it as an inference, where there's something else within this context. There's actually down a little bit lower. There's several things actually, and that's why I'm asking these questions. But if you take a picture of that, do a little screenshot, put that in your post to the Discord, that would be cool, or Facebook. The next question. Don't balk at your responsibility. Okay, so here, oh, that's his name. Is it Balk? It's not Balk, it's Balk. B-A. Is it Balk? I forget how to spell his name. It's not Balk. I think it is Balk, but it's a Austrian. Well, anyway, I'll find it. Irks me. Next question. How does this number affect what happens when you change the text width? Huh? Look what happened when we change the text width.
Yeah.
Make the cubes across. Make the cubes across 4 and change the text width to 12. Why is that like that? Why are they all? Why is that like that? Why are they all the same? Why are they the same? What's happening? How is this all related? And why does it go back to normal if I make the text width some special number? What's that special number I just made the text width again?
11?
No. What was it at the beginning? Now I'm going to give away the answer. What was it at the very beginning? 24! Oh my god!
Uh-oh.
There's a relationship right there. I am not going to do more than take this horse to the well. Right? I am not going to go any further with that question. It will be a dissatisfaction, and it will be treating you disrespectfully.
So the text of
we'll
the
leave that as it is.
So 24 is the number of vertices on a cube, right?
Yes, and it's also the initial value for the text width. Think of how that relates, and think of how things are updating. Later on, think about what is happening, what's getting updated, and why do I have to make it go back to 24 to do that? If I make this more cubes across, and so forth, and let me just do this, and go, so if I do this, why does this happen? Watch this, look at how it looks. Watch if I make this 24 now. Boom. Why does that happen? Why does it happen every time? Then it gets all messed up. And I'll go down here. Then I go back to 24. What is that? What's going on? That is a step along the way to having you master the art of the foo that lies on your path.
So it's just a matter of whether the number of cubes is aligned with the size of the texture.
Write a technical essay. It's not due now, by next week. write a technical essay, mark it up in LaTeX, okay? Write a technical essay on this. Dive deep. You will love it.
You didn't even grade my homework. Why should I do that?
I did read your homework. Oh, I didn't say it. I didn't give you feedback yet. I didn't write it up. I was withholding.
Oh, really?
I'm so sorry. I
really?
did not.
I didn't realize you were grading.
Everyone was perfectly correct. Some of them were kind of open-ended, right? Everyone was correct the way you answered them. It was beautiful. It was a breath of fresh air. Again, it gave me goosebumps. It's too late to make up for the fact I can never undo such a, a terrible wrong.
Just
Please.
move forward.
I'll just move forward. How does changing the text width affect what is happening with these two lines specifically right here? This is allowing you to dive deeper.
So it's
these two lines appear elsewhere in the code. This is part of the mystery that lies before you. What does changing the text width affect what is happening in these two lines? You go find those two lines in the code. It's actually down here in the, right? You see what's it doing there? It's right? It's setting a value for this data, and it's declaring a local variable, right? It's declaring a local variable called UV, right? It's declaring a local variable called data, and it's sampling from the texture. Oh, I'm saying that word. I shouldn't be giving that away. Sampling that data. It's declaring a local variable called UV. It's performing this, right? Performing this set of operations in this expression. I want you to take time with that. This one's not due until next week because I want you to actually include a small technical paper, and you can submit it to your journal of your favorite journal, your favorite graphics journal. Okay. And the last question for this one. What does changing the text width back to 24 always guarantee, and why? Well, you can see it visually, describe it in words. This is where you get the benefit of, so if I do this, look, it's just messing things up. Oh man, you're just mucking it up again. What are you doing there? What are you doing? It's at 24, but if I go away from 24 and I go back to 24, boom, it's pretty good again.
You're getting some sort of gradient alignment. I'm not sure what the term is.
Yeah, you're going to put that in your own words. It's going to be beautiful. Things are going to happen. Things are going to happen. Neurons are going to fire. Connections are going to be made. All right. What is changing? Everybody's learning is going to be independent of each other's, but similar in certain ways, and overlap in certain ways. What does changing text width back to 24 always guarantee, and why? That's going to be a different path for you, right? That's going to be a different path for Mignon and everyone else, right? Sure. So, it is.
All right.
We're going to comment out line 69 now, right?
Yep.
Comment out line 69. I'm going to go down to the fourth exercise. I didn't even put an uncomment method right there. I'm guessing that you probably know which line to uncomment at this point. What line should we uncomment for the fourth exercise?
72.
And what?
72. Line 72.
Yeah. Awesome. See that? I don't even have to front end load this with as much instruction. You already know. You're already down. You're already down. Well, you're on board. You're already down with the program.
All right.
All right. So the next one, we're just going to set the
X and Y.
Refresh the page.
Yeah.
Set the X and Y and Z.
Okay.
For our friends in the UK.
Oh, this is very different.
It's different.
Yeah. So we're gonna set it to 200, 200, and 0. X is 200.
Okay. Let me just refresh this here. X is
200.
Negative 200, right?
Oh, is
Y
it?
is 200. Z is 0.
Right. X is negative 200. Y is 200, and Z is 0.
And then I'll just close I'm just going to close my controls. Close your controls after you've done that. Look at what's going on there.
I can't get to 0. Oh, I guess I can type it in. Okay, 0.
Type it in.
Yeah. Close controls. Yeah, that's interesting. Yeah. How about that?
All right. Those are all pieces of the same function. Looking at it from that vantage point, right? Looking at the projection.
Mm-hmm.
Looking at the projection on the XZ plane, right?
Yeah.
Yes? Or no. Is it yes? Yes. We're looking at the projection along the XZ plane. Each of those segments together is part of the values for different ranges of which function. In other words, let's answer that question I put there. First of all, why do we see smooth cube position change along the X direction? The X direction is the way we're looking at it right now. X direction is up and down, the way that we're looking at it right now.
Okay.
The X direction, the way that we have the eye looking, looks up and down. Why are we, according to that, with respect to, I can say with change along or with respect to the X direction, why are we seeing smooth cube position changing?
It's like it reminds me of like a graph calculator when you type in
exactly right. So, yeah, and what function is it a graph of? Look below at the line below. What's it a graph of? What function?
A power function? Is that what you're saying? Power. I don't know. It's a vector.
Yes, yeah, exactly. It's a graph of the power function that's been scaled down quite a bit, right, with that scale factor.
Okay.
It's a graph of the power function. And it has a very low, right? Right? It has a very low base. It's barely, and this goes to what? The R naught, right? This goes to the R naught value in the COVID-19, right? Because the R naught is R naught is the base number, and whenever that R naught value is over 1, right? Then we have that curvature that we're seeing exhibited over here, right? Seeing that curvature that could just, and that's just barely above 1. So that's pertinent also to the COVID R naught value, because we can think of that as being expressed in a power function. So why is that changing uniformly, smoothly along with respect to the X? I could also, rather than saying with respect to X, which is more mathematical, I just said change along the X direction. But now that we're getting more mathematical here, why don't we say, why do we see the smooth function with respect to X?
It's somehow like the way like a child inherits the position. It's like either like, but it's instead of being additive, it's like well, I mean, you could, yeah, a position is adding the multiplied power to each subsequent cube somehow, like as if each cube was a child of the previous cube somehow.
I love what you said. So perfect. To each subsequent cube, because you know the instance ID talks about the subsequent cube.
I didn't realize that, but now that makes sense.
Now you see why. Because the instances, the instance
right.
ID are smoothly varying with respect to X.
Right.
That's why. That's why we get that smooth function. It's because the instance IDs are changing smoothly with respect to X. Now this is kind of right. This is discrete. This is not typically smooth, but this is like the I'm just using the word smooth in a very loose term here. Because if I was teaching like real and finite analysis, we make the distinction between whenever we're doing like a Fourier analysis or some type of analysis, we'll do a distinction between the real analysis or the imaginary analysis and the finite analysis.
But somehow when the code passes through to each cube, it's multiplying it's adding the effect of the previous change to the next cube.
Right. Each cube number. So the first cube is gonna not do anything, but the next cube is gonna get. It's gonna be 1.05 because it's just gonna be 1, right? Multiplied by 1 plus that. For the 0, it's gonna be a slight offset. The second one's going to be whatever 1, and then it's going to be 1.05 to the 1. It'll be multiplying times 1.05 times 0.005, and then you would have 1.05 squared times 0.005 and so forth. So the instance ID, as it gets more and more, you're going to get more and more of that offset. So forth. All right. I think we have enough of the brain churn to move to the last exercise because I don't need to belabor this anymore.
Right on.
I think we're good here. The fifth exercise requires you to uncomment 4 lines of code, 75 through 78. You can do that in the glitch IDE. You can highlight the 4 lines and do command / to uncomment them all. If you commented them that way, but I didn't. I realized I didn't comment them that way because it didn't put in the. It will put in like when it does that, it will put in like a invisible character.
Sure.
But I didn't. So we have to physically go. I physically put them in there. I didn't realize I physically put those comments in. But if I didn't physically put them in, you can uncomment them by highlighting the. Just like that. So you'll be looking. So we'll just let this speak for itself. Go ahead and run this one with lines 75 through 78 uncommented. Run it. Now go and change the state according to what that state says right there. The state should be 3 cubes across, 1 cube down.
There we go. So we got our 3 cubes across, 1 cube down, right?
And then, and then you can zoom in on them as well.
By the way,
you already know how to do that. So I figure you already know how to do that.
For me, by the way, every time I reload, I change the code, I have to actually type the /
.2.html, yeah.
/ 2.html, yeah.
Oh, really?
Yeah, I have to do that every time. You don't seem to be able to have to do that. I don't understand why.
It's your Chrome settings, I guess.
Oh.
Yeah. Power user. Just joking. I don't know.
Yeah.
I randomly go into the Chrome flags and settings and just click stuff. I don't know what I'm doing. Sometimes I do that because I don't know.
It's pretty funny.
I don't have a life. But okay, so what's it say now? Modify the logic. Oh my gosh. What? Modify the logic below to single out instance ID, the instance ID 1. I should say the instance that has ID 1. Single out, I should say, the instance, I should speak proper English, that has instance ID 1. So modify the logic below to single out the instance that has instance ID 1. I gotta go back and fix that. I feel so bad. Modify the logic below. You can get away with changing
Modified logic
Actually,
below to single out.
isn't it 0, not 1?
Single out the instance that has instance ID 1.
No, but I think you're singling out 0, not 1.
Well, if it's an
No,
array, if it's an array, if it's an array.
I'm asking you to modify the code so that you
Oh,
can.
you want me to change it? Oh, okay.
Yeah, so I'm going to use the synonym modify, in this case, to stand in the place of the word change.
All right.
And I'm going to use another synonym today, logic, below, to refer to the code.
So are the instances stored as an array? So like the first instance is 0?
Correct.
I feel like I need to look up how to reference something in an array real quick because I'm forgetting.
I think you're overthinking things, my friend.
Can I just put an equal sign there, like instance equals 0, instance ID equals 0?
Instance ID equals what?
0.
What's the task?
What can I say if instance ID equals 0? Is that a way to reference the?
Well, you could say that. You could say that. Does that number make sense in terms of the task that has been?
Okay, modify the logic to below. Oh, I get what you're saying. So modify the logic below to single out the instance that has an instance ID of 0. Okay, so.
And there is.
Oh, okay. I get what you're saying.
Right answer. Oh, sorry, there is.
Okay, so geo position is matrix times position.
I love doing open-ended questions. I do that all the time, and then I get to something like this, and I'll say, and there is no right answer. On this one, there is. There is a right answer.
All right. So geo position is greater than 0.
Well, apparently it's not double equals, so what is it?
Yeah, try it.
No, I did. It's not. It's giving me an error. So, the triple equals? I don't know.
Can there be a period there? I recognize the putting a period in my code like that.
What did I tell you? The instance ID is at least in the rendition of the GPU code.
Oh, okay.
I don't know what Minion said okay about.
That's good, because that you shouldn't be looking on her paper.
Right. Okay.
I didn't get an error, so I guess that's okay. Seems to be working.
Did it work? Is lovely Gunto. It worked. This gets us closer. This gets us closer, and this is what I call the pre-lesson.
Eric, I have another question. I thought you were never supposed to use equals with floats.
Oh.
Because of rounding errors and stuff. You just have to set it within epsilon.
You shouldn't, unless you're well aware in the context, these are really all defined on the JavaScript side as integers. So they're not going to have any trailing anythings.
Okay.
So the period is to reference a float?
These aren't, in other words, these aren't computed. All these values, none of these values are computed values, right? All these instance IDs, I typed them in on the JavaScript side.
Okay, well, I mean, that doesn't mean that the GPU isn't converting them to floats. I don't know.
Well, yeah, they are getting converted to floats, but they're all getting converted to floats.
Exactly.
They're not going to have any trailing. They're not going to have any trailing zeros. And 1 point is equal to 1.0 for the. It depends on the actual system that you're dealing with, I guess, technically. For how you express that. You're right. You're absolutely right when you're composed, and that's when we're going into the.
I'm not following.
Practices. Well, if we look at that right now, right, we got the middle one. Now the middle one's getting all. blown up. We blew up the middle one. We can say, oh yeah, we blew up that one. And we'll really jump down the road here to like the third presentation, when we understand the low level thing of how could we use a array? How could we use array, and we can use that array to pick a particular instance and then blow it up?
Yes, that's what I want to do. That's my goal for.
Okay.
We're not there yet. We're not there yet.
Well,
I know.
I've got the first
with
instance.
3JS.
The first.
Are you gonna do that without using 3JS? You can do your own raycaster.
Well, eventually, that's my plan is for like that's for the third lesson.
Oh, okay.
So I mean,
I think I'm gonna take a shortcut myself and do it with 3JS.
Yeah.
So
this is.
We already have a raycaster.
Yeah. Sorry, Micah.
So yeah, if you put double equals 0, then the first instance is blown up.
Right, but we want the middle one.
You want the middle one, so you put a 1.
Yeah.
Okay.
Because
And if you wanted the third one, you'd put a 2.
Because for our situation, what it was before, less than 1, it was logically equivalent to equal 0 in our situation. Right?
Okay.
Because they both isolated. They both filtered out. They were both filters for 0. The 0 is 1.
Okay.
Because we had the set containing 0, 1, 2, 3, blah blah blah. So the element equaling 0 is the same result of filtering as doing the element or the set of elements less than 1. Still that single element 0.
But we've done. But we've solved this question on the 5th exercise, right? Or is it something else?
Yeah. So now, this is purposely the 5th exercise, and this is purposely where I decided to break it off. This is the cliffhanger.
Okay.
This is the cliffhanger because what could you do at this point? You can't do everything you want to do. Obviously, there's several things you would want to do that you can't do. But you can start to do something that you want to do, and enough to allow you to progress on your own. Yeah. That is what I believe is the state, because you've now isolated a single instant.
Yeah.
Right?
Yeah.
We've isolated it in a certain manner. This was a certain technique to isolate it.
Yeah.
Another technique will be to create an abstraction of array basically using a type of parametric line equation. Right? We could use a parametric equation for a line, right?
Mm-hmm.
We can just use a parametric equation for a straight line. We can also use that as a technique to where that line is going to be, or we can specifically say we're going to start that line from one point and march it. We're going to march array. Mm-hmm. So basically we'll use a parametric equation starting at one point, and we will march array from that point to do that. Yeah, to do the next, or two things down the road. But before then, there's still other things we want to do. What are some other things we want to do? That's up to you. That's why it's a cliffhanger.
Nice.
Because maybe you're hanging from both hands and you just don't have the strength right now because you overexerted yourself and you can't pull yourself up right now. Maybe you're holding on with one hand.
Yeah.
Maybe somebody else has a foothold already. So we're all at different points in different states of cliffhanging.
Well, no, I mean, what at this point, this is like a mind-blowing, like the potential and the meaning behind what has happened here should be mind-expanding to anybody, because you've taken something that's mesh instancing and you've individually modified the vertices of a single mesh instance, and you're also demonstrating this this gradient of a texture, of a color texture, multiplied across many different procedurally generated cubes.
So you'll have a lot of questions that you can ask yourself or continue to answer the questions that I've posed.
Yeah.
And in the first place you're going to start, before anywhere else, should be what? Just read this code. It's not that much.
Yeah.
The first thing should be to read all the code. And the second thing I suggest, doesn't have to be, I suggest the second thing after you read the code is then to go through the entire README. Because I took multiple days to go through and whittle down what I wanted to show here in a certain order.
Wow.
Right?
Yeah.
With some things that were tangential to get you thinking about this stuff. And then to also empower you to step out to do more native things and then work with IoT devices as well, and just to understand the math behind some of it a little bit better with really awesome people. Like now I'm gonna find John. Oh, John.
Yeah. Wow.
J-O-N-C-A.
Thank you for
J-O-N-C-A-A.
There you go. All right.
Yeah.
Oh yeah, I like this guy.
Yeah, I posted him in the Discord before.
Yosha Bach.
Yosha, that's what he says.
Yeah.
So I'm gonna post that. Another one of my favorite people ever.
Excellent.
And then we're gonna do one more thing.
And I'll
one
post.
of my favorite.
I'm gonna post all of your notes into the YouTube notes after the live stream is over, and into the document.
Ashley. Come on, where's it going? Oh, here it is. I'll let you go through all of her things, but I love her compiler one. She is amazing. Yeah, and she was over there, you know, at what NPM just recently, or at Mozilla. You know, Scylla cut jaws NPM. She was like over there, like she was CTO at NPM, I believe. CTO at NPM, and then she was the. Did she do CTO at Mozilla too? I forget. That's what she was doing. But I ask her questions from time to time when I have questions about compiler systems.
Yeah.
Yeah, she's a teacher too. She's in the New York area, so yeah, she's amazing. All right. Yeah, so that's all. Yeah, that's all I have. I just thank you for having the patience.
Well, thanks, Eric.
Thank you, Eric. This has really been amazing, and you put a lot together. Do you want to do an overview of everything that's in the?
I can do it. Yeah, maybe a little reflection. I will say that the next lesson we're gonna actually work with the first thing that shows up when you do that. So we're gonna be using another a utility function that's built into their.
Oh, so Lindsay said thank you for this lesson. I'm learning a lot.
Oh, thank you, Lindsay. Thank you, Lindsay. So I was going to use this particular. One right here for next to do the next lesson. These vertices aren't specified in the same manner, kind of explicitly hard coded in. They're generated with an API call in the TWGL, so using a little bit more of their sugary API. But the nice thing about the TWGL, and part of what I expect you to do, is to go through this whole thing. Remember
Wait, Eric, you're not sharing your screen anymore? Did you?
Oh, I'm not sharing my screen. I guess I could for a second. One more second here. that we.
Well, it sounded like you were talking about something that was on the screen.
Yeah, right. I was, yeah, this is, my brain. Bad thing. Okay, so over here in the README, in particular, the next lesson, I want to focus it kind of around here. I wanted to experience the time with you so I can hear your questions, hear where you were at before I kind of, right? Because the teacher has to be dynamic, and I'm a guide. I'm going along with you because I have the things that I got to research, and just like right, exactly what Mignon was teaching me about the compiler directive being there, and I'm actually using a different dialect of for the compiler to compile. So it has different rules, different tokenization rules when it's creating the binary. So I'm going to use.
I wonder if the texture is like repeating on every surface.
Every cube on this one, so you can see. I'll tell you right now. Every cube is just not every surface.
Not every surface.
Every cube is getting a texture on here. So we'll think about ways you can extend that. So we're going to dive in, understand how this works, understand a little bit about maybe some other questions of other things you would want to do with instancing, but at the same time realize that under the hood, they're not really using like in the WebGL. So if I go over to, for example, to convince yourself right here, if I go over to that, where's that one link? The docs.gl. If I go to the docs.gl site, type in INSTAN, you can see draw elements instance, draw arrays instance. These are everything that has even just the word instant in it. What's one thing that you don't see in here that you might be familiar with in the 3JS set?
Well, they have instance meshes in 3JS.
They have instance meshes and instance buffers, right?
I was actually thinking of the word buffer. Yeah.
Yeah. So they have instance buffer and instance meshes, and those are, right? Those are just instance because the instance buffer has to go into creating an instance mesh. Now you're getting a better idea, right? Because the mesh is basically, you can think of the mesh as which one of these things that's going to be on the screen here in a second. A mesh is basically what? It doesn't have to be. It can be represented. These are still abstractions. These are abstractions at the in the graphics level, and these are even used across other APIs. VAO and VBO are used with CUDA. They're used in Vulkan. They're used in other graphics APIs as well. So the mesh, in our case, the mesh is, we can think of the mesh as a vertex array object, a VAO. And then the buffer will, each of the buffer is going to contain different attributes, like vertex position, vertex colors, could be texture coordinates, could even be, you could even put the texture buffer data in there. You can even put the image buffer data in there as a buffer. But that technically would be not, because you're already got the UV. If you have the UV or the texture coordinates, then that wouldn't idiomatically be the place to put in the texture data. You should put the 2D texture data outside of that. And you might have other things using that data differently. Well, it depends on your use case, right? Because these are just containers that you have to basically call these into scope. These are different buffers. You're kind of calling them into scope behind the scenes. They're getting called into scope before the actual draw calls are made. So you want to have anything that needs to pretty much happen in your program that are related to one another. at any particular time be in the same vertex array object.
That means that someone could modify the vertex colors, and you could save it to persistent world. You could modify the post-it vertex colors, or vertex positions of a post-it.
Right. Well, that's
yes, you could.
The image that I've had in mind.
Right. Once you have the IDs, if you think about over here, you can also think about, you're going to get them automatically, right? The IDs. Whenever you have, if you have something instanced, you can get those IDs automatically. Like Mignon was saying, or like I did, I had to explicitly put them in. Either way, just say I was doing it either way, you have a bunch of just like integers counting, just like natural numbers or whatever. And you're going to map those. You can map those over to any other. If you're using this vertex array object for instances, and you don't have to, because you also would use this same container, this same abstraction when it comes to merging geometry as well. You just use it in a different pattern when you do that. But you could use those instance IDs and map those over to the different vertex colors, right? And get the vertex color, and you get the, right? Because you'll get the vertex color when you put them in there as attributes. And then you can vary them based on the ID. Because if you look in the code there, I'm not going to do too much. This is called direct instruction. But if you look right there at the top of the shader, right, we have attributes. The attributes right there are digging into that VAO. These attributes could be stored in different VAOs, because these attributes are basically coming from VBOs, right? These are coming from VBOs. In this case, all within the same VAO.
Sorry, VBO is the B is for buffer?
Vertex buffer object.
Okay.
Right, and you can see down here in a video, I have you go through in an order and a progression that after a while just reinforce a lot of things, and then it finishes up here at the end with a little video and images on.
How so a buffer is opposed to an array, right? So how is a buffer different from an array?
It is linear memory, like an array.
Okay.
An array is a kind of like a more complex thing than a buffer. A buffer, you typically will only have a pointer into a buffer. The abstraction of an array will usually also have some utility functions that are also within its natural scope, like what we'll say is the primitive array for a particular language. Like even within the WebGL scope, is going to have utility functions that are on that primitive that will be within that scope whenever you instantiate an array. You'll always be able to do different things with it, like the index, like in JavaScript, right? The index of is a utility function that's built onto the prototype. They're using prototypal objects in that case. But yeah, an array is very, very similar. It just has more stuff on it. It's just, just the more complex, it's just more stuff thrown onto a buffer. A buffer is basically a super simple array. You can think of it that way. It basically just only has a pointer into it. You only play with the pointer, with offsets, and how much memory to read. Because the next thing that is going to interact with buffers basically are like the words in the instruction set for the assembly, right? Right? In the assembly, you're going to go to, that's going to move your pointer to somewhere in memory, right? In assembly, you're going to go to someplace in memory, and then you end up reading through those each of those bytes in memory, and then you can organize them and put them into some variable value. If it was in a stack machine, you would do it that way. You would operate on the things within the stack. This is different though, right? This is different because you're operating on them before you're drawing. But the idea is a lot of times when you're drawing on the same data in the same state. There's so much data that's not going to change. Every time through, before you call a draw call again, a very small fraction of the data state is going to change, typically. And that's one of the things. That's a really big thing that really cries for, let's use a state machine abstraction rather than a stack machine. But anyway, yeah, I've already.
All right.
Okay.
Clap for that. That was really great. That was my mind has expanded many times. This was like really a great lesson.
See, I know you want to teach me more. That's why I put the effort in, because I know that you're going to teach me much more. and the community is going to grow because we're going to post into the community, because we see so many repeats of questions. And you bring up a good thing about the Slack. Think about how many questions in the Slack or repeats across different channels, even across the same thread or the same channel, or are hidden in replies. We need to get out more in these communities and let the community grow more and more. And then the more literate we all get as a community, the more that we will be able to work together. Like I'm considering, working with the Virabella team next month, at least for a couple sprints. I don't know if I'm going to do full time with them, but I was thinking at least work a couple sprints with them. And if we're going to work with people in the community, it just helps everybody else out to do your best to feed into the system, I think. And I think you really opened my eyes to that a lot by how going back this past week. One of the first things I did is I went back, I wrote down your questions. I went back to all your videos. I watched all your videos. I watched some of them before, but I watched all your videos.
My videos?
Yeah.
Oh.
Hours. Yeah. Some of them hours long. While I was cooking, trying to cook fine ketogenic cuisine.
Great.
Same time. Yeah. But yeah, definitely.
Amazing.
So have you tried yet doing this in 3JS, Eric, or are you just using this TWGL or whatever it's called?
I'm actually gonna hang out at the TWGL level. I was thinking about next week doing it in raw WebGL, but there's a lot of this setup that kind of busies up the code with setting a bunch of enum state at the beginning, and then calling a bunch of setup functions. Like for example, in the README, I even point out in the important sections to read from TWGL.js. Oh, I even put it in the code somewhere too. Wait, somewhere in the code I even put. But anyway, I forget where. I think I commented it somewhere else in the code. You'll read it when you read the code. You're gonna read. It goes through the links for if you just go to the API and just read the docs for TWGL, it's good because a lot of best practices and a lot of approaches, it's that lower level, and it actually is better than just, because I read a lot of 3JS. I've read a lot of it. I read a lot of the leading up to the rendering pipeline to get to just the basic renderer. And I did that a long time ago, but a lot of that's even changed. That was old 3JS. That was back like 2011 or something.
Yeah.
But a lot of it's changed since that. And now they're even going with a whole different nodes system for doing for composition of shaders. I didn't notice if you noticed I don't know if you noticed the beta.
Wait, I don't know. What do you mean by nodes?
So if you think about like the nodes kind of like a flow, you ever study like flow languages, like it's a visual programming paradigm, where just like in Blender, if you're doing the nodes in Blender to compose shaders in Blender, or you can do it for animations too in Blender. A lot of things, even Shader Frog. You play with Shader Frog, right?
So
I think I just saw it because you
so
did something.
nodal programming can be like visual programming, where every programming block is like wrapped in a node, and then you just like connect nodes together, and then that's how you construct your an argument. That's how you construct an argument.
Right. So the idea is, and they're almost they're almost one-for-one functionality in the nodes branch. It's a different branch on the 3JS source code. If you go to the nodes branch,
I gotta look at this because I never even heard of it. I've spent a lot of time
maintaining it.
Yeah, I've never heard of it either.
It shares. It gives me goosebumps. It shares a lot of things that I love. That's why I'm doing the CS1 game.
Would Vertex node be an example in the 3JS documentation?
Yeah, there's a whole node section if you go into the source code. There's like a folder right there. Let me get 3JS nodes branch.
Do you want to share your computer for this this part?
Yeah, you can just. I just typed in. I would just read this article first before even reading the code, to read kind of like the rationale behind it from this one person. I have other rationale. My rationale was kind of like, we can have so many awesome, really easy to construct GUIs built on top of it, and actual game engines built on top of, directly on top of 3JS. Because you can start, if it's nodes-based, you can start building nodes-based GUIs. Because they've already done this with the C# libraries, like the C# library that interfaces with the native OpenGL in Unity, in the Unity C#. They already do this. That's why they have like nodes composition for shaders. They have like plugins in the Unity store that you can buy them. Like the free ones, but I think there's some free Unity nodes composers. But
all right, do you want to share any more links relevant to what you've been researching and this project?
Wait, but is there anything in the 3JS repo that's called nodes?
Yeah, in the repo, just go to 3JS GitHub.
Yeah.
And then in the repo, just go into the repo and then open up the repo and search this repo.
3JS GitHub.
GitHub, right. Search the repo by clicking on
in examples there's something.
And then search for, what am I searching for?
Example. Well, you can even see by going to examples nodes.
Examples nodes.
Okay, I'll look at that because I never even heard of it. Okay.
From GitHub, from 3JS.
Yeah, that'll give you a better guide. Looking at the examples, using a destructivistic or reverse engineering method of understanding is good, because that's what we're starting anyway. But yeah, I'll paste that examples in the node one in the chat, so you can see how that's actually used when you're coding things. But imagine what I really like about the nodes is you can start building the GUIs on top of it really easily. Or let me get the other one. I was just going back and forth with somebody at the Slack this last week about this in particular. Let me grab that real fast. I am in the GLSL area. Where is it at?
I mean, these examples, I have to put this in like a prettify or something, because it's not coherent the way it's written. But anyway.
Yeah. I got two more.
You got two more links down there, or one more link down there?
Yeah. Let me get this one here. This is just a proof of concept.
Oh yeah.
This is even before the Nodes project was really going full blown. This is This was kind of early on. He's still working on it now as the Nodes project is really doing awesome. Let me get right here. Because I'm composing, with the way that I'm composing the API, a lot of people say, well, you're throwing around the word domain-specific language API. What do you think? What's going on? It's like, here's the reason, right? Because when you're doing something, you want to speak, when you program, you want that language that you're reading, the code, the text that you're writing, to be as close to the application context that you're dealing with, first of all. That's one, right? That comes from, that's even in the book, that's Uncle Bob. That goes back to Uncle Bob days. And clean code and all kinds of things like that. The clean code book. But the other reason is, that since it is at that level, what's another consequence? And since if you write your APIs nicely and at that level, and you write the APIs, the actual functions, in an overloaded manner, then you have so many ways you can build like GUIs on top of it to make like graphical ways to make the game, to make actual like what Unity is and what Unreal, the actual graphic interface. You can make them so easy once you have the underlying code organized that way. Yeah, so I just put in the chat with the one that says Dusan Bosniak, test node.
Yeah.
Yeah, he's the same. He's the same person.
Like a demo or what? I don't know what. I can't tell what this is.
He's the same person actually that wrote that article. I guess I could have. I think did I post the? I posted the article too, didn't I?
I mean the yeah
Node,
it's by him.
Node-based shaders article.
Node-based shaders. Yeah, I posted the article for that, right? Yeah, node-based shaders. Yeah, Dusan is the guy that wrote that anyway. Dusan Bosniak. And he's the guy that, you know, that's that's his website right over there. So he wrote that article on Medium, and then that's his personal website, thedusanbosniak.com. And that's the proof of concept. It's really like early days, but once you do the underlying structure of your code in a kind of like DSL nodes kind of fashion, you can just start building on top of it in a very minimal code or code or no code or low code fashion, right?
Okay, but this nodes thing, it sounds. So I was asking you kind of why you're using TWGL instead of 3JS, and you started talking about nodes. So are you saying that's a reason not to use 3JS?
To understand, right, because everything, if we think about the basic idea of encapsulation, whether you're using classes or components or whatever, typically in 3JS, at the 3JS, they'll use classes a lot of times, right? They'll use classes, they'll use sometimes just JSON with a bunch of different, sometimes they'll just use like JSON literals with a bunch of functions as certain things. You know, but usually they'll use a class encapsulation system, right? Object-oriented programming.
Wow.
So whenever you can understand the encapsulation and the abstractions that are involved better if you take some time and spend it at the TWGL level, read through their documentation, because you can look at why they wrap certain chunks of setting enum state in the WebGL and calling certain setup functions in WebGL. You can see what makes sense to do at the same time. That way you're not fishing through the whole WebGL set of enums and function calls.
All right, well, maybe I should spend some time looking at it, because I started looking at it because I did do that homework, and I did enough to actually convert that code into use WebGL2, but in looking at the TWGL, I started thinking this is not a tiny library. This is a big, complicated library, and I don't know if I really want to spend time learning yet another library when I know that I want to use 3JS.
You will use 3JS better by using that better. If you learn to use that well, once you learn to use, that well, then you'll be able to, if you even wanted to at that point, use raw WebGL. And why would you want to understand? So you understand the memory layout, you understand at the lowest level. Then you'll just be able to choose the functionality, the abstractions at the 3JS level much better. You'll just buzz through your code much faster when you're coding at the 3JS level.
Yeah, I agree. I agree with that. That makes sense.
You'll also be able to read like Python add-ons for Blender, because Blender basically uses the same. It's using WebGL to do Blender. So you'll be able to then understand these like Python add-ons and so forth. You'll be able to understand even Blender better, and other tools in the ecosystem. It even doesn't have to be Blender.
Yeah. This is like learning
your own add-ons to Python or whatever.
Yeah. This is like learning the basic vocabulary of a language. It's a lower level understanding, and it does like the nodes are sort of like, I'm imagining that a node is sort of like a way to wrap text in a way that does take the place of 3JS or Babylon.js, but not necessarily. It's almost something like you could probably use a node in combination with 3JS or Babylon.js. That's what I'm thinking.
So having all these 3JS, what the 3JS did is like they kept on doing these different material shaders. They were different. Then they would have to consequently do a different renderer. Now they have to make a different renderer. If you look through the 3JS source, you see they have all these renderers. All these different different material shaders, different renderers, things that are specific to them. Because as we learned today, under the hood, it's really about using VAOs and VBOs and calling WebGL functionality into them to manipulate them, and then calling your draw calls, in elements or whatever you're going to draw, arrays, whatever the draw calls are. So it's just like the chunking, everything. Just thinking first, I'm going to chunk into renderers, and I'm going to have these different renderers. I'm going to have the orthograph. I'm going to have different.
So I'm just thinking of the network efficiency of being able to, if you're just pulling in, objects that are basically VBOs or VAOs. Into your VR program, that might be more efficient than trying to, use objects at a higher level in A-Frame or 3JS. If you just, in terms of like how much, I don't know if this makes sense, but it seems like, you can get very specific about just modifying, individual properties of individual vectors with a call to your server. I don't know if that's more.
Absolutely, you might have a little bit less source code, but you will have a lot less draw calls once you start using them correctly. A lot less draw calls. You'll start to reuse a lot of colors, because once you think of, is you can, I'm storing my color variables, like right now I'm thinking I'm going to store all my different design system sets of colors and stuff, and I'll store those in map, JSON mapping with the colors and what have you. But if you think about that on how that would happen on the GPU, I'm going to have a vertex buffer object. I could have a VAO I could have a VAO with several different like design theme VOs in it. So I can have each design theme. I can have a different VBO that's the same VAO. If I think I'm having switching between them.
You know what I'm thinking? You know what I'm thinking is that, if you're operating with augmented reality and you're operating in the real world, and light is always changing depending on where you're standing, which direction you're facing, and what time of day it is, and what's in the room, and like, so as that could be one of those things that you could be changing objects based upon the lighting, and you could be like calling, someone enters, a reflective object enters the room or the TV turns on. There's all this new light, and you could be fetching stuff from your server that just like makes micro alterations to your scene based upon what is being detected in the room.
So you're familiar then with foveated rendering, right?
Yeah. Yes.
Because foveated rendering, you basically have there's an extra chip that's on the board for the VR device. That extra chip is just a special machine learning AI chip. There's AI everywhere, but it's a special one, even specialized for foveated rendering, for the linear algebra calls for foveated, even specialized down to that point, where the way that the operations that happen on that. So it's not even a GPU. It's not even a GPU at that point. It's because it's not dealing with all these other abstractions that the GPU has to implement on top of its assembler. It's just simply doing what's necessary for foveated rendering, and that is going to be before we know it exposed in R. You can already start to turn it on in the Quest, right? You can go in, and you can already go into, you can already turn, as we know, like this week, we can already get hand tracking, right? Did you try out those examples I posted?
Yes.
Slapping the 5 and that.
So I didn't try that one, but I tried several of the others. I want to try that one. That's on my list. It's on my list.
So some of these features that are worthwhile come at a little bit of a compute cost on the hardware end. So if we're doing less kind of dancing back and forth between, user land like CPU land and GPU land, if there's less of a bandwidth between the GPU and the CPU, and the GPU can keep a lot of that linear memory, as much of it, not changing as much over time, then that's going to be a big win. And these optimizations, a lot of the optimizations, in this in this era that we're living right now, when we're really beyond the point where the microprocessors are getting twice, doubling every 2 years, and so forth. We're not at that kind of curvature anymore. That exponential growth is not occurring at this point. We're getting a little bit, kind of close to it, but we're doing all these other. It's not coming from that. We're getting performance increases from other things, but not even as much. We're not getting any. We're not getting clock speed increases. That's been gone for a while. The whole thing of clocking and how to create a clock and how to create a fast clock. Since we can't get any closer, right? Creating a fast clock is only as fast as how fast you can read it, and the noise between point A to point B in the circuit. And the noise, depends on what kind of silicon you have, the quality of the silicon, and the clocking techniques that you're using on the actual hardware architecture side. So this is important. It's important. The more we get down closer to the chips and understand them, because we're going to realize there's going to be more APIs that are opening up for different chips that might, in the general community, they might just come to you as this big, super high level thing. But once you start realizing that this is actually going into different chips on some device, like a VR headset, then you can start to code with a different mindset, because you're thinking more, I know where this is going. I know where this line of code is going to affect the next chain, the next thing in the event, the event chain, and so on.
All right, so that's it's time for it's that time again. I want to thank everybody for coming to the meetup tonight.
Thanks, Micah.
And good night, everybody.
Good night.
Good night, Mignon. Good night, Eric. Can't hear you anymore right now, but bye-bye. Good night.
Good night. Good night.